Discovery, go and throttle up. Discovery, go and throttle up.
Here, what about this one? You guys might like this one. Oh, it's over here. There we go. There we go. Yeah. Is this what? Is this good? Oh, yeah. It's like a workout song, man. The Avs finished the sweep of the Oilers. Dude, I heard the game last night was really good. No, not the tough. No, I'm good. I'm good. I'm just vibing. That's what the kids say, right? Sorry, just gotta vibe for this part. Then we'll start. Could say a lot of things that I'm way too old to understand. Because you didn't see my post on Discord yesterday. Really cool truck that we had at work. Oh yeah, that's neat. Yeah. All right, let me see. Yeah, it's a shipping container. That's cool. Party parrot. All right. Well, hey. First off, guys, I didn't stream yesterday, but yesterday was the 6th of June. And, yeah, that's the anniversary of D-Day. So, if I stream, I always find it important to at least say something about it. So, yeah. How far are we out? We're pretty good ways out from D-Day. What is it? 78, I think. But, yeah. One of my big things with spaceflight is history. You got to learn the spaceflight history or else it repeats itself. And that's not just true for spaceflight history. That's true for just history. You can see people being dumb in history, and then you can see it repeat itself, and you go, oh no. So it's important to not forget that stuff. And actually, today is the anniversary of the last battle at Midway. Yeah, 1942. That Midway was a critical turning point in the Pacific Theater, where the Japanese lost 4 carriers in one day. Yeah, that was the end. That was the end. That was the turning point. They had nothing left. They couldn't recover from that. Yeah, Josh, 2-time World War champions, bro. Undefeated. Undefeated, am I right? Am I right or am I right? Whoosh. Hell yeah. All right. Anyway, with that being said, Creeper, let's check this out. We all thought it was so cool. So these guys put a TEU on the back of an Isuzu box truck. See that? That's it. Yeah. See, that's a TEU. It's a Connex, just a shipping container. That's a small shipping container, though. That's cool that they put this on the back. Yep. That's an Isuzu box truck. Cool. It's Japanese truck, but see, that's cool. That's cool. They got a kiln in there. They got a brick oven built in right in there. That's pretty neat, man. That's pretty neat, dude. Yeah, that's a hell of a food truck, if I do say so myself. The whole kiln is in the back. That's pretty cool. That is a pretty legit food truck. And then it's got, oh, look at that. They put window doors on it. Oh, okay. I see what's going on in here. That's pretty cool. You'd make a moving Chinese restaurant like that? Dude, I've always wanted to do Asian Italian fusion. So, okay, all right. Think about it like this: beef and broccoli on a pizza. Let your taste buds kind of pick up on that real quick. See what I'm talking about? See what I'm talking about? Dude, it could work. That'd work, and it would be really, really good. Yeah, yeah. It's my opinion that an aluminum or carbon composite version of a TEU with minor modifications will become the industry standard method of transporting most cargo in space. We're going to need something like it. We need, like, Asian Italian fusion. It needs to be like that. How about, like, we gotta combine two things together. Sure. Make a killer carbonara, yeah, and I cook Asian food all the time. I totally see a bunch of pasta dishes with Asian stuff. Yeah. You're American, you have no say in cuisine. I didn't say nothing about anything that... What are you talking about? What does that have to do with Asian-Italian fusion, Oxy? Because your country is known for whatever it's known for? I don't even know what your country's known for. At least we're known for something. And Hypersonic ain't American, man. He's America Light. I'm just kidding, man. I'm just kidding. Orange chicken pizza? I could get behind that. Oh, boy. Alright. Alright, guys. We got Kerbal to play. We got some Kerbal to play. But first, I kind of want to show you guys this. How about butter chicken pizza? Yeah, I could do that, Aztec. I could get it. I could get down on that. How about we flip this? How about we do like Mexican Chinese fusion? How about that? Imagine like a beef and broccoli burrito. I'd eat that. Beef and broccoli burrito with some white rice. Or with some pork fried rice. Holy shnikes. Pork fried rice, beef and broccoli burrito. I'm in. Kung Pao tacos. Yep. Okay, alright, we gotta stop. Orange chicken penne, I could get in on that. That'd be good. We had a killer night with dude from our American partners last week, by the way. One is from your area. They were in Montreal for the week. We had so much fun. Very cool people. Right on. Wonton chimichangas. I'm in. Yeah, Aztec. Hell yeah. Yeah, but just try to keep it clean during the day, man. I try to run family friendly during the day, which I know is not the norm anymore. But anyway, let me get the joystick out. Oh man, I'm sore. I climbed a mountain on Sunday because I could. It's not really a mountain, it was a hill. Whatever. So, boss, I've been playing Stationeers the last few days, and the update is awesome. Can we do a fresh start on whatever body you want and enable the derelicts? Well, no, I don't want to do it because you want to, Tessa. Yeah, now that you've said something, I'm probably not going to play Stationeers at all. Yeah, it's mostly because of you. I do the opposite of what you want. Yeah. Sorry. No, I was talking to Dean, actually, over the weekend. Well, not over the weekend. I was talking to him when he was streaming. But I'm like, yeah, I want to play Stationeers. Yeah, we want it. We should do that. Also, here, look at this. Look at this guy. Look at this. Yeah. Yeah, I thought that was pretty cool. Also, the first ever like fully 3D printed rocket is being integrated at the at Complex 16 at the Cape. Yep. Do you think she lives? Oh yeah, she lives. This is coming from Relativity, guys. Look at that. That rocket. Look at it. It's all 3D printed. 3D printed metal. Apparently, there's a Pez dispenser at Boca. Did you guys see? Just on a quick side note, did you guys see Elon's his hands-on meeting video that he posted? Where was it? Where was it? It's in. I mean, he posts. That guy posts a lot on the Twitterers. Here, let's try this. SpaceX hands-on. Her. What is it? All hands meeting? I don't know what it's called. I don't know corporate speak. There's a video floating around about, hey, GrabShark, you need to see this. Oh, I like that picture a lot, W. That's nice. It was an all hands meeting, and they showed where is it? I'm trying to find the thread. It showed Starship and how it dispenses payloads and stuff. I forget where it is. I'm gonna have to find it. Oh, wait, I got it. Here, look at this. It's a reverse milling so how Relativity does it, Aztec, is a think a stick welder. A stick welder with feed rod. So like almost a MIG. It's basically a MIG. I don't know if it's exactly a MIG, but it's some kind of welder. And they have a 5-axis mill, so it's spinning, right? And the thing just goes like this. And it lays the bead, and it makes the tank. It's just a welder that's feeding. All that is just welding beads stacked on top of each other. It's kind of crazy, actually. It's some kind of welder, dude. I don't know if they're using flux or arc or TIG or whatever. I doubt it's TIG, but it might be. Dude, it's ridiculous. They have videos of them dude, they just zip up a tank. Like, obviously it's sped up. The thing's just like, zip. It looks like somebody, like, massaging a clay pot, you know? Like, you have the spinning things, and they have the clay, and you make, like, a pot out of it. Dude, it looks like that. It's very, very strange. But here, check this out from the all-hands meeting. I wanted to show you guys this. So the body of the rocket and the tank is printed together. The rocket is not, no, the rocket is not printed as one piece. If you know anything about printing rockets, right? Or 3D printing anything, you don't 3D print it all at once. You 3D print a bunch of different parts. They have a 3D printed rocket engine and a 3D printed tank, and then they have to put it together, just like any complicated 3D printer. Speaking of that, I gotta pack up my 3D printers. Remo and I started packing yesterday, just on a side note, but yeah. Yep. The engine is mostly 3D printed, hypersonic. The only thing that's not 3D printed on those rockets are like bolts and nuts, and that's about it. So you start with a bunch of nuts and bolts and a bunch of like metal powder, and it'll make you a rocket, which is, like I said, that's pretty damn impressive. Yeah. Well, Tessa, we're past appraisal, so I'm pretty sure we're pretty sure this is gonna go through. Once again, I'm not popping the champagne until then, but Dr. DJ, homeowner. I talked to my realtor and everything, and everybody else that's kind of involved with this process, they all said start packing, so, alright. Started packing up non-essentials. I know, Aztec. It's pretty sick, isn't it? Here, speaking of ridiculousness, check this out. This is from SpaceX's all-hands meeting. '10th anniversary of the first Dragon flight. Thanks, GSF. Wait, that's illegal. First civilian crew to the space station. First planned spacewalk with Dragon. Are they gonna go outside in the flight suits? When do you think we're gonna see Starship fly? July? The payloads are, believe it or not, the jeez, can you believe that? The payloads are the bottleneck for Falcon Heavy. They have the Falcon Heavies ready, guys. Those rockets are ready to go. The payload is what's delaying the Falcon Heavy missions. Isn't that nuts? That's very strange to me, because it's usually the reverse of that. But yeah, grab. Crazy. Yep. Here. This is where this gets crazy. Oh, but they have no SAS. Will they have to depressurize the entire capsule? Yeah. Yeah, there's no airlock on there. So they're gonna have to depress the capsule hypersonic, which is Gemini style. It's dangerous. That is dangerous. But hey, SpaceX thinks they're up to it, dude. Look at this. Look at this. Look at this thing. What in the actual frick is that? Checking the suit? They have Jared Isaacman is paying for that, Josh. That's the Polaris Dawn mission, dude. Where have you been, by the way? Is everything good? I haven't seen you in a bit. Yeah, that dude, he's paying for that. Isaacman is paying for that, and he's like any of the proceeds, he's using it to support St. Jude, which is pediatric cancer research. It's really, really interesting stuff. It's a space Pop-Tart dispenser. Yeah, unbelievable, right? They're gonna do this. They're gonna do that. That's what they're gonna do on the first OFT. I'm pretty dang sure. And those Starlink satellites are freaking gigantic. It's a freaking Pez dispenser. And it did it. So how do they launch them out? Springs? Oh, I don't know. Are the Starlink sats going to be larger? Those Starlink satellites are way larger, RJ. They're quite big. Ooh, piece of candy. 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 Isn't that nuts? And like I said, Ship 24 has this. It has that built into it. It's crazy. And this gets even crazier. Look at the end of this video. The end of this video is nuts. So Ship 24, look, it has the Pez dispenser built in. See the payload bay? With a higher capacity of V2.0, this is the equivalent of almost 600 V1s. It's unbelievable. Are those the ones that will use lasers to communicate? Yes. Ship 24 and Booster 7. Guys, this makes me feel feelings that I didn't think I did. Oh. Oh my. I know, Grab. I know. It's so legit, dude. It's so cool. Oh my gosh. I know, Greg. It so is, dude. It so is. Oh, dude, I don't even know what to say. Bruh. I know, Greg, I'm with you, man. I'm so excited about this. You know, Elon may say people need to be excited about the future as a marketing ploy, but also, I hate that I fall for this, but that's so damn cool. Damn it. Well, that basically confirmed what we were thinking. That connector road right there is designed for heavy infrastructure. You know how we've been staring at core samples and road grades for this for the longest time? Well, that basically confirmed that. Greg, whatever, dude. Nobody's above criticism, you know what I'm saying? You can criticize all you want. You can criticize all you want, fine. Alright. But Greg, I think that actions speak louder than words. And you know he's making this. So, hey, criticize all you want. That's fine. Go ahead. Oh. Yeah, Josh, I'm with you, man. It'll be cool. It'll be very cool. Dude, I don't have any other words. I'm not so sure about the geodesic dome on Mars in the Mariner Valley, but hey, you know what? We can dream. the whole geodesic dome thing might take a little bit of time. So what you're saying is SpaceX will try and harvest the xenomorphs. Yep. Greg, careful. Anyway, I thought that would be a good primer for KSP. Yeah, Jen, I'm with you. I'm with you guys. Sometimes, dude, I don't like swearing, but sometimes swears are warrant exclamation. Like, you swear when you don't have anything else to say, you know? Like, I get it, you know? I just need to see them catch the booster. I'm with you, RJ. Did you see this? Delayed until at least the end of the month. Yeah, CRS-25, it has some hydrazine problems, guys. SpaceX is having some problems with their hydrazine valves. No, I'm not making that up. SpaceX Yutani. Yes. No, it's all good, Greg. Don't worry about it. They will need to build additional No, not pylons. Supply depots. What do you think? We're some magical freaking space wizards or something? No. You want a piece of me, boy? Jacked up, good to go. Rock and roll. May I have some shoes? AK-47s for everyone! Sorry. Yeah, Cirrus. Yeah, Grabstar, you think you throw that one by me? Hell no. Yeah, SpaceX 25 is having some problems with... they had a leak. They had a hydrazine leak when they went to fuel it. It's not a big leak, but it's a leak nonetheless. You gotta be careful with that. Have you ever played StarCraft on stream? I don't play StarCraft on stream. Or... I've never... I've played it like once or twice, Hypersonic. I stopped playing it on stream, and this, like, dude, I haven't played it since like 2013 or something. I stopped playing it on stream because StarCraft really rustles my jimmies, and I used to get really mad at it. And the reason why I used to get really mad at it is because I wasn't smart enough to figure out why I was losing. Dude, I was Gold League at best with Terran. I would just BC rush people because spaceship, and usually lose because I like BC rushes because spaceship. I mean, it makes sense when you think about it. Yeah, that's what I wanted to do, Thron. Yeah, I started streaming on Twitch because I wanted to play StarCraft professionally. So started doing it every day, and then I realized that I suck at that game, so I stopped. Hey, Madford, what's up, man?
Discovery, go and throttle up.
I was Gold League at best, Hypersonic. My brain just... I'm sure I could give it a good shot nowadays and learn and understand it. I'm sure I could, especially with chat behind me. I would have chat backseat the hell out of me if I'm playing StarCraft, but Hey, 17-month resub from Mick. What's up, dude? Now you play KSP professionally. Yeah. It's a fun game. I do enjoy StarCraft. I still enjoy watching StarCraft, too. I don't get to watch it too much, but yeah. Yeah, maybe, Kralani, yeah. Yep. Have you seen the new BMW race car? I haven't. But guys, if you guys like wrenching on cars, you like some of the car stream stuff that I do, watch Mad Ford. Mad Ford on Twitch is just all automotive streaming all the time, and the name precedes because he does build some pretty awesome stuff. Make sure you go over there and give Mick a follow, okay? Good buddy of mine. Mick, I am like this close right now, dude, from closing on a house that has a 1,000 square foot garage in it with high ceilings. High ceilings. Have you seen the latest project? I haven't, dude. Link me. High ceilings. Concrete foundation. High ceilings. You know what I'm saying? You picking up what I'm laying down? Yeah, Nick, you get it. See? That's why we're friends. Yep. I'm this close, dude. And when we get it, I am going to start fixing all the crap, all my junk projects. We're gonna start fixing all of that. It's a shop with crew quarters. Little office built into the back, dude. All right, what do you got for me, Mick? We're gonna get into KSP, guys. I got to do more work on the MLV. Oh, hell yeah. Yeah. What do we got here? Duratec Focus RS, fully forged engine, MTX 75 RS transmission, bolted into Mark IV bonus, wiring and ECU from Omex, plumbing next, fabrication to Super Duty, heavy drive shaft. Nope, forward. Come on now. Get out of here. Oh, yeah, forged Duratec. Oh, this thing's gonna scream. This thing will scream, man. Hell yeah. What else do we got? Guys, she's got a snail. Fully forged, 350 horse car that weighs 800 kilos. This thing will scream. This thing will scream, dude. Oh, yes. Oh, yes. Oh, yes. Oh, yeah. Yeah, that's good. Dude. Yeah. Yeah, it's got to be a little bit stronger this time around, huh? Custom. I was gonna say that's not factory, man. Is that a poly bushing in there, dude? That's. Yeah. No, this is doing it for me. Yeah, this thing's gonna go. She gonna fly. Yeah, I was gonna say that mount ain't stock. Did you section this out? Because I see the seam sealer right there. You had to section it to fit the motor. Transaxle, right?
Discovery, go and throttle up. Hey,
Azako, what's up? Phil, I'll show the SLS rollout stuff. The pictures are fantastic. Yeah, baby. That is some mad engineering, dude. This is good stuff. See this right here, guys? That is engineering. You need to really know what you're doing if you're going to cut into a subframe like that. And Mick knows what he's doing. Trust me. You guys want to see some sick wrenching like this? Go give him a follow. He streams every day. And I wouldn't say that if I didn't mean it. I mean, oh, that's freaking nice, dude. I love it. I love it. Yeah, this thing's gonna haul. This thing's gonna go so quick, dude. Cable gear change? Yeah, that thing's gonna haul. And it's gonna be light too, like you said, 800 kilos. That thing is going to really go fast. Like if you're worried about the torque steer, you're gonna hit the gas and the wheel's gonna go this way.
Discovery, go and throttle up.
Just. Oh, that's some rev limiter fun right there. Yep, that's cool. Thanks for showing me that, man. Transverse mounted. What torque steer? Yeah. Aside from the one wheel peel. Full throttle gear change and launch control. Dude, you're a freaking animal. You're a freaking animal, dude. I like that, Hellfish. That's cool. You're a freaking animal. That is minty fresh right there. Sweet. I'd rather push a car than pull it. Yeah, Greg. I'm generally kind of a rear-wheel drive kind of guy. But Mark IV Escort with 300 horsepower, front-wheel drive, I'm okay with that. I'm okay with that because the car weighs nothing to begin with. It does. When your car weighs 800 keys, it doesn't matter if the engine's out back or in front. Like, I mean, it does, but that's fine. That thing will scream, and it's pretty dang fun. That car is probably really fun to drive. Ah, yes, got a good diff in there. No wheel. All right. Yeah. Very good. The customer hadn't got the budget to convert it to rear-wheel drive. Dude, with a car like that, when you're running a Duratec, a forged Duratec like that, who cares? Who cares where it is? Like, don't get me wrong, I'm not that big of a front-wheel drive kind of guy. I'm more of a Sierra Cosworth kind of guy myself. But who isn't? Like, who isn't, man? Obviously, right? Are you gonna... My first car is a 79 Mark II Escort 1.6. Ah, very good. Very nice car. I understand some of these words. Grab Shark, amongst other things, car guys like rear-wheel drive cars. It's like, okay, front-wheel drive to rear-wheel drive, like, it's going to give you better weight distribution because the drive wheels need heavier components, so you get better weight distribution. So, generally with a car, you want the center of mass to be kind of equidistant from all four wheels, but that's weight distribution, right? You don't want the weight too far forward. You don't want the weight too far back, right? Because if the weight's too far back, what happens to stuff that's moving through a 3D environment when the center of mass is out back? Think tail-heavy airplane. Tail-heavy cars are susceptible to the same thing. They will snap oversteer, right? Front-heavy cars are susceptible to something called understeer. So basically the moment the engine has over the center of mass of the car will make it want to keep going in the same direction. But if you have a light car that's front-wheel drive with a very small engine that makes a lot of power, you're not as susceptible to that because the engine doesn't have that much moment over the center of mass of the car. Like I said, it's like balancing center of mass and center of lift in Kerbal with an airplane. Cars do the same thing. Can you guess what I just bought? The Kazi. Kazi was four-wheel drive, two-wheel... Oh, that's... Yeah, okay. Nice, Beardston. There you go. I rolled it on a dirt road. Well, at least you sent it, Greg. That's what matters. So, grab, like, the reason why people are like, oh, rear-wheel drive, front-wheel drive. With the rear-wheel drive, you get way better weight distribution because all of your components are, like, your drive wheels need to be stronger, right? You need the drive shaft, and then you need the differential out back. You get way better weight distribution with that. Now, shall I send you a pic? Mick, obviously send, yeah, duh. So, that and, you know, if your rear wheels are pushing, right, you get better weight transfer on acceleration. Like, grab the other thing is, like, loading and unloading suspension when you're driving a car. This is super important for cars that turn left and right. I mean, don't get me wrong, it's important for, like, NASCARs too. The weight distribution is really, really key. Here, I actually can show you a good example from the Belle Isle race if anybody watched that. The Detroit GP was yesterday, and it was really good. It was a really good race. I'm trying to find the right part here. You could see the car unload the suspension, which is unreal. And you're, like I said, certain components have moment over other components, and they can decompress your rear suspension. And decompressing suspension or recompressing suspension, like if you bump the suspension the wrong way, it's like a Kraken strike. The car will just stop carring. I'm trying to find a good picture of it. You saw it very, very clearly from the Indy race here. Yeah, here we go. All right, here, I got you. Watch this. Hey, Chronos, 14-month resub. Okay, that's Jimmy right there. Watch the next car going around the corner here, okay? The one that says United Rentals on it. See that? See what it did? That's bad. They didn't get the suspension dialed in right. You see the car bounce around? They unloaded the rear suspension, and look what it did. It went, what the hell? See, watch the United Rentals car. Look at that. You see that? That's no good when your tires are doing this. That unloaded and reloaded the rear suspension real quick, and you bottomed the suspension out, and the car didn't know what to do. See, the car just went that way. It was going this way, but now it's just like, nah, I'm gonna go that way. Physics basically divides by zero. It's just like, I don't, whatever. Looks like he took the turn wrong. He said later that the suspension wasn't dialed in correctly. I think that's what he said. But see that? Oh, that's no good. This is the kind of stuff, like, this is the reason why people like rear-wheel drive, front-wheel drive cars, because when you're going around corners, you can load up the suspension. The moment of different components over the center of mass of the car will screw with you. And if you unload the suspension, this is a rear engine, or this is a mid-engine, these are mid-engine cars. The center of mass, look, you unloaded the rear suspension, and look, the momentum took you in a different direction because the engine has moment over the rest of the car. Look at that, car is off the ground. See that? This is why there's like, oh, people like front wheel drive, people like rear wheel drive. It doesn't. The truth is, fellas, and I once again, I like rear wheel drive cars. The truth is that it doesn't really. It doesn't really matter. It's more about weight distribution and setup. You could drive anything fast. That's the honest truth. Mick, you got a new picture for that? I'm waiting for him to link up a picture. The bottom of the car took the weight off the wheels, reducing lateral traction. Yeah, loading and unloading the suspension, and that comes from where different components are placed. Excuse me. But yeah, look at that. Oh, jeez. Yeah. The car's just like, nah, no. Isn't that crazy, dude? I think that's super interesting to me. That's as interesting to me, Grav, as like how planes fly and stuff. I love that. I love this stuff. The reason why I like that stuff so much, dude, is because like you could see cars working in physics, and this is stuff that you can do in your garage. I mean, ask Mick. This is stuff you can do out in the shed. You can work on cars and you can see the physics working. It's like it scratches the same itch as like rockets, but you can't work on rockets in the garage, right? Like, all right, Mick, what do we got? Oh, yeah. Oh, I love it. Oh, see, that's what I'm talking about. You can if you try hard enough. Yeah, right. That's what I'm talking about, dude. See that car, fellas? I like this car. It doesn't look like anything, right? It just looks like another sedan from the 90s. This thing has a 2.3 dual overhead cam Cosworth engine in it that's turboed with rear-wheel drive. So what does that mean in plain English? This little unassuming car can be cranked up to like 500 horsepower and it'll blow the doors off of anything. These things were made for homologation rules for British touring cars, meaning that it's basically a race car underneath, but it looks like a regular car. They're awesome. They're one of my favorite cars that the States never got. It's got a T5 in it. Oh. Is it a 2.0 or a 2.3? I don't see. We never got that Cosworth engine over here. It was a 2.3 for us. We got the Lima engine in those. 2.0. Oh, we need that Cosworth motor over here. We need that we need the Kazi engine. We never got those things, man. We had a Vega Cosworth with mechanical fuel injection, which is all right. How's the 2.3 worse? Well, Peg, it's a single overhead cam engine, but they did put that 2.3 in the Mustang with a turbo from the factory in '84. It's called the Ford Mustang SVO. And the funny thing is that that thing was faster than the V8, and Ford discontinued it because it was faster than the V8. True story. Yep. Yeah, no, can't have that. Yep. You guys never got the Barra. I know we never got the damn Barra. That's a shame. We do have a motor that's kind of like it, Greg, but it's a truck engine. But those truck engines are still cool. It's like a single overhead cam Barra. They punched out an inline 6 to 5 liters for trucks, and gave it a single overhead cam, and put those in trucks. It's a 4.9. That's what they call it. It's a 300 cubic inch inline 6, which is 1 liter more displacement than the Barra. But the thing is that the thing is designed to make torque. The stroke is like much as the Statue of Liberty, man. But we had something like that, but it's a truck engine. Yeah, Hellfish 4.2 Atlas. I want to take a 4.2 Atlas, dude, and find one, port it, machine it, turbo it, and then put it in like an IROC or something. That would be cool. Yeah, there's just not a lot of support for them, but they are everywhere, dude. Or Hellfish, you know what we should do? Take the entire 4.2 out of a Trailblazer and put that in like a 4th gen Camaro or something, all-wheel drive. Because frick you. Trailblazer, you could get it done. It would be a lot of work, but you could do it. Hang on, we'll take an engine picture. But yeah, these cars are fast as hell. And because they only have a 4-banger up there with forced induction, you get really good weight distribution. You should see these things zip around the track. They're really good.
Hey, babe.
Yeah.
Discovery,
I started trying to pack up some of the stuff in the kitchen.
Okay.
And I realized very quickly that I'm not qualified to pack the special plates. Like, I don't feel...
Our fine china?
Yeah.
We'll do it. I'll do it.
Okay.
Yeah, it's no problem.
But in the meantime, there's a big plastic storage bin in the kitchen. So I'm like...
Okay.
Do you want to look at it and break or something?
What do you want me to do?
My ideal scenario is that you would come help me with this right now, but it's not urgent, so you're trying to, like, work. But...
Yeah.
So I'm like, no, not really, but...
I'll take care of it a little later tonight, okay?
Love you.
Love you too. We didn't do it. But yeah, I follow Rob Dom and stuff. Yeah, absolutely. Hey, Vasia, what's going on? Guess who finally can pay for stuff? All right, man. That's good. Mick, we got another picture? Picture of the motor? Ah, it's making me log into Instagram.
Discovery, go and throttle up.
That one is making me log in for some weird reason. Huh. I don't have an Insta account on the computer. The boss has spoken. Stuart, what's up, man? Nice decoding of the situation. Sloppy, dude, that's one thing I've learned, man. Cut right to the chase. Just cut right to the chase. What do you want? What do you need? Don't be a dick about it, but just what do you need? Just tell me what you want. Tell me the ideal scenario. Dude, trust me, that works. That works real well. Yeah, it still wants me to log in, which is strange. Yep. If you know, guys, you know. Or girls, whatever. If you know, you know. What do you need? Just tell me what you need. No bullcrap. Tell me what you need. That makes things way easier. That's something that I should have done from the start. With other relationships, I've screwed them up very badly because you don't play those games. Don't play the games. And I'm not saying there's like some crazy weird thing going on. You just got to communicate. That's one of the keys. Yeah, Greg, I hear you, man. I hear you. Except when you get the "you should know what I need." And then you say, well, I can't read your mind. You gotta tell me. Talk to me, Goose. Straight up. Yep. Speedy. Yep. Exactly. You got it. Beerston, you get married on Saturday. This stream is a great little escape from all the honeydews I have this week. Yeah. Yeah, Mick, that one ain't working for whatever reason. I'll log into the Insta, dude. I gotta log in on my phone though, because this is where I have it. Because I'm an idiot and don't know how to use it. It's true.
Discovery, go and throttle up.
Bingo. Oh, ho, 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 ho. I don't hate it. Panta, what's up? Yeah, I got it here. That's that. I'm gonna do the boomer thing and show a picture. Hell yeah, there she is. That thing screams, dude. That motor sounds like a pissed off bee when you rev it. It's like freaking awesome. Yeah, that's money, dude. That's money. Top Gun Maverick, best movie of 2022. All right, MLV stuff. Let's go. Man, we have a disadvantage. We're not telepathic. Yeah. No, I made sure to make that clear, Speedy. Yeah. The ideal scenario is EJ packs everything and Bremo doesn't have to worry about it. Yeah, see, Speedy? See, there it is. See, boy. I have some experience with this now. But I have some experience with this now. That's just, yeah. I'm off to the pub. Have fun. Much respect. Hell yeah, Mick. Hell yeah. That's awesome. Guys, go give Mick a follow. Trust me on that. I wouldn't push it so hard if I wasn't sure that was content that people wanted to see, you know? Trust me. Go give him a follow. He does good work. And he teaches the stuff too, which is the best part. Mick, I still want that damn motor. That Rover, what is it, the K series that has the head studs that go all the way through. The head studs go to the drain pan. Why don't more people do that? That's such a good idea. Alright. 1 pint for every person in chat. We'll never see Mick again. Never see him again, man. Alright, fellas, let's get the tunage going. Alright, we're working on the MLV today. So, let's get some stuff done. I want the landing legs. We got to get those landing legs finished. If we can do that, then we can go screw around with that the shuttle build more. I've been seriously contemplating trying to build the shuttle and the pad for fun, just to see as kind of a side project, but the MLV still remains my priority here. Fixed legs or cracking legs? I wanted to do legs like this, telescopic, that do something like that. It shouldn't be too difficult to get that done right, but yeah. But we gotta be careful, RJ, because this can't just be hydraulics that point down. The reason why they can't just be hydraulics that point down is because they'll drift. They'll drift whenever I load and unload the vehicle. I gotta be careful with that. Why don't you just tell Drummer to do the packing? It's not a bad idea. SRMs means solid motor. That's right, Robot. Hold the solids, all right? I like liquids because liquids are easier to reuse, okay? Do you have a set date on when it should be finished? No, Phil, but I really want to get this done sooner rather than later. When do I fly over? Yes? My wife wouldn't hit the enter key too early, Neo. I'm just kidding. Fix would be so easy. What's the downside? Namely pad integration, Josh. It would be hard to balance this around the pad hold down points. That, and I don't want to give the wrong impression like you could have a fixed landing leg that's behind the rocket nozzles, because it would melt in real life. I don't want to give people the plausible realism. That's always been my thing with this. It's always been plausible realism. So landing legs really shouldn't be beyond this point, guys. And then my hold down points are right here. Now, don't get me wrong. We could go re-engineering this stuff if we really want to. I could do a different type of hold down as well if we wanted to. But, once again, I don't want the landing legs to extend beyond the nozzles. I don't think that's right. I think that's going to... See, that always invites a weird type of dialogue in the stream. And the dialogue is this. Oh, well, you can fix landing legs there. You know, why doesn't SpaceX just do that instead of folding out legs? Well, in reality, that's a really complicated question, because you're dealing with all kinds of thermals, all kinds of aero, all kinds of vibrations, all kinds of drag that gets made from the landing legs. I would prefer something that's plausibly realistic, just to make sure that we're, you know, peddling the right kind of mentality about spaceflight. That's something I've always been very particular about. Hey, Sea Kraken, what's going on? Wouldn't Kraken bearings help with the drift? And wouldn't they drift if... And would they drift if you lock them out? They still drift if you lock them, RJ. Yeah. This is vanilla. Yeah, Robot, I don't have anything against solids. Solids are fine. It's just tough to reuse them in KSP. How I play, fellas... So you see this booster right here. If you notice, this booster has a bunch of RCS thrusters sitting on it. Why? Well, what's that about? Well, I want this booster to come down and land next to the launch site. But I'm not talking about hitting the recovery button. This is a way that I enjoy playing the game. I'm not talking about hitting that recovery button when this thing comes back down. I'm talking about getting a crane, picking this thing up, folding the landing legs back up, and putting it back on a launch pad and launching it again. Those RCS balls are there because they're a hold down point. See this? See the thermometers there? That's a socket. And we plug the booster in to the socket, and we have reusable hold down points. I want the booster to be reused. And I'm trying to figure out the simplest way to do it. Right now, the simplest way that I've been able to come up with, the simplest way to do it, to get that booster back on the pad, is to land it back on the pad. That's the simplest way in theory, though. We try to pull a SpaceX here, we're going to have a bad day. It is insanely difficult to try and get something that precise. So the next thing that defaults into my head, like, okay, we could do what SpaceX did. What about catch arms? Let's just say that I've prototyped that out too. Catch arms are... It's hard to do, Robot, but your boy here has like easily over 10,000 hours in KSP. When you get this far into KSP, doing challenges like this is what that's what lights my fire in the game. You know what I mean? That's what keeps me going. I love doing stuff like this. Let's just say that we've tested catching boosters before. It does work, but also it would be insanely difficult to get done right. Let me show you. So this is a little test device that I've made here. And we do have a fixed landing leg solution on this prototype booster here, but watch. Well, because they would be destroyed is a very vague answer, Hellfish. I usually don't like inviting that type of dialogue, you know? Hey, Civex, what's going on? Yeah, Robot, I really like pushing the envelope. It's fun for me, dude. This is how I enjoy the game. Alright, so we go down here. The first thing that we do is undock that booster. Ignore that. The craft file is glitched. There's just a piece of it that likes to just pop up over there. But, you know, like, robot, I could reuse SRBs, right? By basically taking them back here. To, like, you know, if we get an SRB space shuttle style, we parachute it out in the ocean, we go get it, we bring it back, right? We could do that. That would take a long time because I'd have to have a small navy and a pier and stuff, and that's expensive in real life, and it's very time consuming. Hey, Motoman, what's up? Thank you for the 5 subs. I appreciate it. Now watch this. We may or may not have started screwing around with SpaceX's chopstick design. And we made the linear bearings on it. It's your birthday today. People have been so nice, so I figured you'd pay it forward. Well, I appreciate that, man, but you don't need to gift me subs on your birthday. I should be gifting you a sub. Inifodia, 1 year. 1 año. Gracias por los streams. De nada, amigo. Soy el fiesta. Boom! No, I know that was terrible grammar. Alright, watch this. So, let's take the booster, turn RCS and SAS on. Alright, so don't worry, that was just the docking port. I understood that reference. So, like I said, I could get a booster on this thing. It would be very difficult to do this coming back from space. Ready? That was the wrong way to do that. Don't pop the bearings out. Okay. We can do it, fellas. It's doable. Very difficult, but doable. Keep in mind, this is just a prototype. I'm not sure if I could figure out a better way to do it. And it's not to say that's when I say a better way to do it, it's not to say that SpaceX's way isn't fine. I think this is what's going to work in real life, but I'm not sure how practical this would be in KSP. You don't have the engineering mode text on. Oh, okay. I got you. So, once again, we could catch boosters. It's doable. I'm not sure how doable it is, though. At this, like, if I can't reliably do this, and I can't in KSP unless we, you know, maybe get KRPC going. I mean, KRPC might not even be accurate enough. I don't even know. Like, basically getting software to code this. No, I never put it on here, Ska. And honestly, the idea of KRPC is growing on me. Coding our own guidance systems, because I was talking to Rockets to Guns the other day when I rated him, and he showed me his scripts. He showed me KOS and like how he automated everything, and I was like, okay. Can you code? No. I'm sure I could figure it out, Josh. Dude, the way I see it, I don't know anything about coding. I really don't. But I can do this, and I know that mechanical engineering and software engineering are two different things, but it's the mentality, you know? I think I could understand it. I'm not stupid. I mean, only a little bit, maybe a lot. Okay, maybe I am a little bit stupid, but if you do it for the love of God, start simple. Yeah, of course. But see, there you go. Config files are not coding, FYI. Oh, thanks for the vote of confidence, dickhead. I appreciate it. called disclosure, you dickhead. He has to. I'll figure it out, guys. I know I look like a Neanderthal, but I'll figure it out. It's not that big of a deal. Main difficulty would honestly be the math. See, Josh, like, the thing is, dude, when you have a clearly cited end goal, coding anything becomes simpler, okay? All right, I'll give you an example. You ever been playing a video game and you have a clear end goal to that video game? The clear end goal could be like, I have to defeat this boss, or we have to defeat this mob, or whatever. Or I have to, I don't know, win this tournament or whatever. When you have a clear goal, and when you see the clear goal, it's very easy to illuminate that path to that goal, right? As opposed to, have you ever played KSP and just jumped into it and be like, I want to build a rocket. What do I want to build? I don't know. And then you just kind of sit there staring at the SPH. I mean, this happens to me too. When you have a clear goal, it becomes a lot easier. And I know what I needed to do. I know the final steps. Like, I know what I want the rocket to do because I know a lot about rockets. The code shouldn't be that hard. It should be... I'm not saying that it won't be difficult to do. I'm saying that I'll be able to figure it out. It'll just take me a while. But I'll be able to figure it out because I know what I want it to do. Now, how I'm going to get it to do that, I don't know. That's the part that's going to be difficult. But I can figure it out. I'm confident in my abilities. I can figure it out, guys. It's really... shouldn't be too hard. I don't think any one particular challenge is going to be difficult. What I do think is me figuring it out. It's going to take me a long time to learn it because I'm a slow learner. Dude, I learn as slow as freaking molasses moves around. I'm telling you. I have a freaking caveman brain. It's going to take a second to get this up here, but it's okay. Get the house, ditch KSP, and we build real ones in the garage. Yeah, that'd be nice. Yeah, exactly, Drummer. I think because I have a need and I know that it might be okay, but I'm not going to lie to you. If we did decide to pick up KRPC, I'm going to need like a month. Like a month at least of trying to figure it out. But that could be pretty cool content. I think that would be fun for you guys, right? Like, sitting here, maybe we'll try to just get the booster to take off and come back down and land. Like, not be caught by anything, but... Plus, you have a chat full of nerds who won't hesitate to backseat your poor coding. Pretty sure we could get it done, man. Just be prepared for backseating. Oh, yeah. No, I know. I know. You know, it's a stream. You're going to get backseated anyway. Where are we with the MLV legs? I haven't gotten too far with it, Ark. I'm trying to figure out what would be the best solution here. And this is what I mean about the end goal. I mean, Drummer, I'm taking CS50 courses, dude. You know that, right? Brimo and I. That's what we do on date night. We watch Harvard's CS50. I'm not saying I'm good at it, but I'm getting it. It's just progress is slow. Make it do AI learning so it gets better each time. I'd prefer a relative navigation solution, but I know that that's way more difficult because, I mean, how the heck would we even do that? There's no optics in this game. David Mallon is his name, Miles. Yeah, he's an excellent teacher. He teaches coding in a very similar way that I teach rocket science, at least in the beginning parts of CS50. He breaks it down, it makes it very easy to understand. It's pretty cool. You can actually do TRN in KRPC KOS for sure. I'm not sure if a relative navigation solution there, GravShark, is what we want, though, because the rocket's always going back to a fixed point. The launch pad shouldn't move. Especially if we use the target indicator as a datum. You know what I mean? If we were landing stuff and if we were using some type of automatic landing, I would have it home in on the target. I would have it hone in on the target. I wouldn't have it hone in on like a point, like a longitude and latitude around Kerbin. I don't think that would be a good idea. Yeah, I would use KRPC because then you'd learn Python. You'd kill two birds with one stone. But yeah. Fair point, but just letting you know that it's possible. You can grab the current spot and ground that your craft is over, extrapolate it from there, and find a flat landing spot. Have that be the new target for landing. Now, Gravshark, I would use that for lunar landings. Yeah, I would use it for lunar landings. Or any planet that, I was about to say exoplanet. That's not right. Any planet that's not Kerbin. Yeah, you would be great for that. For like Duna, for Drez, for Tylo, Elu, stuff like that. Relative navigation would be fantastic. But a relative navigation solution is something that's really hard to do. I mean, how would we get the optics? You need a camera for that. Hey, Alucard. I would love to do it, though. It would be fun. But it would be a little bit of a detour for mission mode. But the payout would be way better. But I don't know. I mean, it really comes down to what our stakeholder expectation is for the MLV. I want the MLV I was gonna say I want the medium launch vehicle to I want it to be quick. It should be easy to turn around. Like when I say turn around, I mean land it and put it back on the pad. I really need it to be simple. I don't know, RJ. I haven't gotten that far, and that's what I mean. If we're gonna, yeah, I don't know. You could use a height map for the surface. Hey, Laggy Bandit, what's going on? Could you just virtually set your position to a whole bunch of points around the current landing location and get altitude from there? I don't know. I was actually going to ask you guys, for the people that have used KOS and whatnot. That shouldn't be there. If I have global positioning satellites, right? Could we use triangulation to have the booster be able to figure out where it is? Or would it be easier to use a closed loop system? Can Kerbal even pick up on a multi-point relay system like that? So like if I have like a ground station, if I have multiple ground stations and the rocket's coming back in, can it use its position, the landing zone, and the two ground stations to triangulate? Can we do that? Doing that in real time would suck, actually. That would be really hard to code. I know that would be hard to code. The static landing legs are growing on you? Vessel position is baked directly into what mods have access to. You don't need position of other vessels at all. Oh, alright. I dig the DCX base. Okay. Can we not do this without mods, or is it not possible in the normal game? Do what? Look at the API. Oh. Oh. Oh, yeah. No, we don't even need... Yeah, we don't even need to do that. Yeah, grab... And Josh, I see what you're talking about. Oh. Okay. Okay. I see it. Okay. Yeah, see, what I wanted is landing legs that do something like this, but... Let's think about this for a second.
Discovery, go and
This is
throttle
the
up.
car stuff I was telling you about. Apple's CarPlay is going beyond the infotainment screen. Oh. That's neat. Yeah, I see it, Bree. Yeah, that looks cool. We were talking about adding a programming mod, no? Yeah, so... I don't know. Yeah, we're adding a programming mod. So, King, I understand that, but how does that make your prior question, like, what do you mean? Is coding relevant? Can we do coding in the stock game? You can make analog computers in this game, sure, but it's a little bit difficult. You'd have to make a mechanical computer. I've seen it done before. This is a YouTube channel called Gordon's Workshop. Watch. Hey, Laggy, I'm just deciding how I want the booster to come back down and land. Can we solve the problem without a mod? Precise landing? Yeah, of course. I could do it the old-fashioned way. Sure, but look at that. You can absolutely make computers in KSP with CAL controllers if you really know what you're doing. It has to be a mechanical computer, though. Yes, this is in stock with texture, with flags loaded in. They have flags loaded in on textures, or Gordon did flags loaded in on textures. Look. Oh yeah, no, Gordon made a mechanical computer. Yeah, so far, he's the only guy I know that's done it. So he's using flag textures, right? But this is the stock game with the DLCs, Watch. You can do it. You can code in Kerbal with CAL controllers. It's possible. There's the flag pack that he's using. Subtitles in Russian. Yes.
Discovery, go at throttle up.
I'm telling you, this is one of the craziest things I've ever seen in this game. This is well beyond my capability with CAL controllers. It's literally an analog computer, like the old school style the old school style computers that use they use trig to calculate artillery trajectories for a fire control system on a battleship. It's just a big mechanical box with levers and switches. Yeah, mechanical computers, dudes. Look. Yeah, this is Minecraft Redstone computer level. Oh yeah, absolutely. Yeah, I forgot the name of it, Potzer, but yeah. Like I said, this is from, here, I'll show you. Gordon has made some insane stuff. This is a great YouTube channel. I'll be honest, I don't know this guy. He keeps to himself. I don't know him very well. But it is fantastically good. This is some of the craziest Kerbal engineering I've ever seen. Guy made Flappy Bird with CAL controllers. He made Flappy Bird. In stock. So you can make, King, you want to make computers in KSP, it's possible. You can do it. I could do this, sure. I know, Sparks. I know. What do you think? I like the new one, dude. It looks good. I know, Sparks. Isn't that insane? The closest thing that I've ever done to this, fellas, is the avionics package on the K92. I have the K92 basically sequence a bunch of CAL controllers to be able to convert the vehicle from horizontal to vertical flight. Yeah, the guy's a legend. That's well beyond what I can do. Here, I'll show you what I can do. Like, could we try to do the programming with CALs? Sure. I could probably get that done. But look. This is something that I literally have a PCB of CAL controllers in here and a little very, very basic input-output system for this vehicle. This is the K92. So the K92 is a autogyro aircraft. It's an autogyro / VTOL, meaning that it can fly forward in flight like a regular airplane and have the blades autogyro. Basically, you tilt the two helicopter blades up like this, and they have oncoming air come at them, and they spin. They spin from the air coming at them, and that generates lift. But it also can hover like a regular helicopter. So throttle those back, push the engines up. Watch. So we can hover it like a regular helicopter, right? Like just kind of like a Chinook or a V-22. And what this does is kind of like a V-22, but it's a little bit different. Like I said, this is an autogyro. The crazy part about this is that I got it to be able to switch flight modes mid-flight. So I could switch it to autogyro mode. The first thing we got to do is just throttle the engines up. Start getting some forward momentum. What's that, Alex? Oh, you're at the gate. Have a safe flight. Exactly, Pigzig. Now, I have my CAL controllers set to be able to switch to flight mode. Ready? Boop. Watch. Okay. Flight mode is switched. See how the right light is on? Now we're in plane mode. So now what we can do is take all the power away from that, and now we're flying on the engines. These helicopter engines, they'll still spin, but they're not making any power. All they're doing there is just being introduced to oncoming air and spinning, and that's the wings of the airplane. See? Notice that they're spinning at differential RPM because I'm turning. That's where the synchronizer comes in. You need the synchronizer here. And the other plane has the synchronizer, but I can make it swap between flight modes, and it's all automatic. There's a couple of control mechanisms that you need to lock out because how the controls for a helicopter are completely different than the controls from an airplane. And this is what in real life makes the V-22 so ridiculous, that it can seamlessly transition between helicopter and airplane with the same flight controls. Why have a synchronizer when you could just crash violently? Yeah, right? See that? That's from lack of synchronization. Those things wobble like crazy because they're not synchronized. They're just they're close, but they're not exact. Pretty much, yeah. I can make a guidance system. It's doable. But yeah, point is that we could program it with cow controllers. I could try. But I think actually just coding the thing might be a little bit of a better solution, but I don't know for sure. Something like that, Altio, yeah. Alright, so now let's throttle those down. Ready? We'll switch the flight modes. Left light is on, indicating that we're now in helicopter mode. Watch this. We can even auto-rotate this thing down. I'll shut the engines off. Helicopter engines have nothing. Let's put those down like this. Watch. We got no engines. So gravity is pushing down on my helicopter blades and introducing air to them. And as we get pushed further towards the ground, the blades spin faster and they actually generate more lift. This is called auto-rotation. I have no engines on this vehicle. And then when we get near the ground, all we got to do is just give me a collective up because we have the RPM, right? And then just... See? No engines on. And that part of being able to do that so easily is the flight computer. My very, very primitive flight computer. Bananas. See? So, computers are possible. I'm just not entirely sure how we're going to do this with landing a booster. How would we do it? With CALs. Is that even possible? Like, I think this is on Kerbal X, Brian. Yeah. We don't need to and shouldn't. Yeah, Ark, I could program the CAL controller. No problem. That's like an animation sequencer on a 3D model. It'll work. Yeah, I could do that. I understand that already. Coding would be able to, but like, I'm not entirely sure. Like, how do we, I could get the engine to throttle, I could do the landing and everything. A, how are we going to do it precisely? And B, how are we going to know when to activate it? If I just say, oh, I'm going to activate my landing sequencer at 5,000 meters, if I activate it at 4,998 meters, that could be the difference between the rocket hitting the ground at 100 meters a second or at 0 meters a second, right? I think the software offers us more flexibility in the guidance system, to be 100% honest with you. Also, this has an includable cargo bay. You can put stuff inside of this thing. It's about the size of a C-130 in real life, and I even made it kind of look like a C-130 from the side. Yeah, exactly, drummer, yeah, see? I also want this vehicle in mission mode for recovery operations. This vehicle is too good to not get used for that. Hey, Red! What's up, man? Thanks for the raid. I agree, Brian. Yeah. Does the game have interactive elements with altitude? Not in the stock game, Alex. There's no way for the cow controller to pick up on altitude, to my knowledge. Like... I'm trying to think. Is there anything that we could do? Can cow controllers read a barometer? No. Red, how you doing, buddy? Cows can trigger cows, can't they? Sure. Yeah, of course. That's how Gordon got the Flappy Bird thing to work. Yeah. There's a bunch of cow controllers on here. For avionics. Like I said, this is a very primitive avionics package right there. Yeah, I don't... And Tessa, you know what sucks is that Maximal was telling me once upon a time that had they chose to keep developing KSP1, they would have added dynamic inputs for the Cal controller, which is it's very sad to hear. That's what they wanted to do. They wanted to make it so a Cal controller could pick up on altitude, so you could yeah. If the Cal controllers could do that, I would just make the system this way. I would make it right in the stock game, but they can't. Which is why I'm like, maybe we should. Could make a mission timer-based control system. Wouldn't be the most precise, but could control the whole mission. Yeah.
Discovery, go at throttle up.
Exactly, Ace, yeah. Hey, Lunchbox Hat, gifted a sub to Red Panda. I'm slowly doing better after a bad time, so that's good. Glad I could raid. Miss seeing your streams. Well, I'm glad that I could make your day better, dude. It's an uphill battle, right? But yeah, sit here and watch me break the game. Right? I think the only way to automate landing is if you automate launch. But see, if we automate launch, there's no way to account for dynamic payload mass. Not every payload is going to be the exact same. Some are going to be lighter. Some payloads will require more delta V if we go to a different orbit, like a polar orbit or something. That's a different amount of delta V. So we either make an avionics system that can put one payload in the same orbit every time, or, which I don't want, that's useless, because a rocket might go to a different destination every time. This is why rockets do roll programs off the pad, right? I'm thinking KRPC might be the right solution, either way, but I don't know. So create different programs for a range of payloads and masses. Hellfish, my mind's defaulting to, well, the amount of time that would take to figure out, I might as well just learn how to code it and take into account for a dynamic input. Just got to implement this. Lossless convexification of non-convex control bound and point constraints for soft landing optimal control problems. Oh. How about doing the opposite? Use time cal logic for the second stage to reach your orbit autonomously while you pilot the booster to a landing. I already do that. That's the paper from Senior Mars Landing Engineer at SpaceX. Yeah, I know who Lars Blackmore is. Yeah, Phil. I know. Anyone know what the full name of the game that EJ is playing? This is Kerbal Space Program, Rudu. You can just ask me, dude. Yeah, KSP, Kerbal Space Program. This is my main game, dude. This is what I've made a living off of, streaming KSP and teaching people about how all this stuff works. Maybe not so much this. This is a little out of my purview right now. I understand what it does, but I don't know the math behind it. I know what it's designed to do. I can tell you what this gibberish up here means. Lossless convexification of a non-convex control bound and pointing constraints of soft landing optimal control problems. This is basically... It's basically a mathematical formula to overcome the inaccuracies of trying to land a rocket in a precise area. Meaning that when you boost a rocket back and land it, it's hard to get that trajectory right. Why? Because at the end of the day, the rocket is falling from, I mean, what's the highest point that a Falcon 9 first stage goes? 70 miles up, 80 miles up there? So, like the apogee is like 120 kilometers or something like that on first stages. Think about it like this. if you are 120 kilometers up and you drop a rock, right? Just like a regular rock like this. What are the odds that it's going to land in like a football field sized area? Very, very slim and none. That's very hard to do. The rocket is like dropping a rock, only the rock is 150 feet tall and 20, well, not 20. Yeah, actually about 20 feet wide. So 3.7 meters by 50. So trying to drop that from that height and get it into the accuracy of a football field is very, very difficult to do. There's a lot of factors there. There's a lot of variables that play into that. Wind, gravity, you know, the grid fins doing their thing, navigating the right target. There's not only, and the thing is that all of these conditions are dynamic. So the wind is going to be different every time you try to land. Almost every single time. The wind is never uniform like that. There are gusts of winds that happen. This thing, that lossless convexification, that refers to basically figuring out a way to make something self-correcting so it lands in a certain area. That's what this says for the most part. I mean, why do you have a rock? Well, this rock is a very particular type of rock, Aztec. It's a river rock. This is Tennessee River rock. Tennessee River rock. I got this from a friend of a friend of a friend. And if you notice, a big chunk of this rock is missing, like the top has been flattened almost. Well, the reason why that is because it's been flattened by an 18 million pound crawler transporter. Yeah, this is Tennessee River rock. It got crushed by this thing. See that thing right there? That skyscraper that's moving? Yeah, it got crushed by that. That's why the top chunk is top part of it is missing. Like it got ran over by 18 million pounds of metal. Pretty cool, huh? They don't give those out as souvenirs, man. That's why I have a rock on my desk. Because it got ran over by that thing. See this thing right here? Is that technically NASA property? It was gifted to me by NASA. I did not steal it. See this thing? The crawler transporter. Yeah, the rock got run over by that. Now, okay, a little bit of a side tangent. Why? Why use rocks? Well, rocks, the rock crushing actually helps absorb the load. It's almost like if you're moving 18 million pounds of metal around on a swamp, you need to make sure that it doesn't fall into the swamp, right? So what NASA does is the crawlerway isn't paved. Pavement is not strong enough. Rocks are strong enough. And the rocks that are on NASA's crawlerway are designed to fragment when they get run over. Because they knew that whatever you put this dang thing on is going to get crushed. Pavement, whatever. And they didn't want to repave the crawlerway every time they wanted to move a Saturn V out to the pad. So they put rocks down. Rocks are a lot easier to replace. You just push down more rocks. Simple as that. Very elegant solution for a very complicated problem. That's why I have a rock on my desk. You can see them right there? Because it was crushed by that thing. That thing with a gigantic rocket sitting on top of it. Are they like rail basalt? Yeah, kind of. Yeah, that's kind of the same idea. See the Tennessee River rock? They use Tennessee River rock in Mississippi and Alabama, I think. For the geologists, they're a porous type of quartz. They're quartz-based porous rock. Once again, these rocks are designed to get crushed. They take the potential energy, the weight of this, and the potential energy, instead of crushing the crawler transporter or sinking into the ground, it crushes the rock. This is like a shock absorber, because most things in Florida don't like having 18 million pounds. Most terrain in Florida doesn't like having 18 million pounds of anything on it before it sinks into the swamp. So that was what they came up with as a way to be able to move Saturn V, space shuttles, everything out to the pad. That thing right there. Pretty cool, huh? Like I said, The top of the rock is missing because it was flattened by an 18 million pound crawler transporter and mobile launcher. How much is 18 million pounds for the metric, folks? Divide that by 2 and that gives you your kilos. Yeah, give or take. So I would say like 8.8 million kilograms or something like that. Somewhere around there. Yeah, it's heavy. Yep. That's why they had to build the VAB 4 times. I don't understand the reference, but yeah. Walking on where the rocks were crushed feels like walking on a tile floor for the curious. Yep. You hurt my brain with 1 million kilograms. That's not how metric should work. Yeah, I know. It's like when NASA says 1/10 of a meter a second when they're talking about the ship's docking. You remember that, Potts? Were you there for that? 1/10 of a meter a second. What?
Discovery, go at throttle up.
I said they couldn't build a VAB in a swamp. Ah, yeah, it says that. But I built it anyway. Fell into the swamp. 1 gigagram. It's just... Okay. Yeah, I know. It's... measuring systems, am I right? Anyway, so, yeah. Going back to it. I understand what this is saying. I don't understand the math to do it. I'm sure if I read it, we could learn it. I'm sure I could. I know I could. I'm confident in my abilities, but I'm not arrogant. I don't know what all this means, but I could figure it out. Especially with you guys' help. I know we could get this. This is very, very complicated stuff. Yeah, that's... Damn. Yeah, that's complicated. Anyway, so going back to what we're doing with the rocket, I'm not entirely sure what would be the best way to get this done. But you know what we'll do? Either way, we're going to need some type of landing leg. I don't think that me coding a rocket that could be caught by something is something that's going to happen in the future, in the near future, at least. So we should probably just kind of go off the assumption that, we're going to land it manually, at least for the time being. Can I get a Wendy's where the title you have is actually a dish, please? Sure. Alright, anyway, let's design this thing. I'll design my telescoping legs. So how are we going to do this? So first thing, I like to orient the local axis with the landing leg. It's a world axis, so this will be easier to manipulate. Alright, so I basically want a telescoping style leg that's going to just pop out like this. And we'll have a housing for it, right? And it's just going to like that. Oh, I implemented that paper once, but bringing it to KSP is pretty difficult. Embers, I'm not going to sit here and even pretend like I would be able to learn that in a month or a half year or a semester or even a year. I know that that's complicated stuff. And that's how it might sound stupid, but that's how I know that I would be able to understand it. Because I know how complicated it is. And, I have experience with complicated projects. So, I think it's important when you start a project, right, to know your ability, to know what you can do, right? I know what I can do. I know enough about coding and I know enough about math to know that that's way out of my purview. That's something that if I decided to learn it, I would need to start a lot simpler than that. I'm talking like getting a rocket to go up to 10 meters and then come right back down and then kind of going from there, Baguette on the moon confirmed. What is this? France will sign the Artemis Accords tonight at the French ambassador's residence in D.C. Cool. So legit question, are you genuinely considering putting KRPC in with KSP, yeah, I don't think, even if they did patch the game, Tesla, I don't think KRPC would mess with that. I don't think there would be any conflicts with KRPC. No means no, yeah, right. There's an easier paper by Michael Smuck on 6 Degrees of Freedom Mars landing. I recommend you start with that one. Yeah, I should. I'll think about it. Anyway. All right. So, hey, Embers, like I said, I'm confident. I'm confident in my ability. It's not arrogance, though. I'm not going to sit here and pretend like I know what any of that means. I don't. But I'm confident in my ability to learn it. Differences, you know? It's the fine line between confidence and arrogance, you know? I think, like, Dunning-Kruger. Like, this is not Dunning-Kruger. I know how difficult that is. I know enough about math and stuff to know that that's a pain in the butt to get right. And I know enough about flying rockets in KSP to know that it still would be difficult. So, and I think once you get to that point where you realize the scope of a project like that and you understand how complicated it actually can be, that is the point when you're ready to start it, you know? So maybe I will. I don't know. What's the first craft you want to build in KSP2? I don't know. Space shuttle. Space shuttle. Actually, I've been making my way through this book right now, Rocket Ranch. I'm annoyed because I creased the damn cover like a freaking bloody savage. I dropped the cover and I creased it. I'm annoyed about that, but hey, whatever. I've been reading Rocket Ranch, which is a book that tells you about all the infrastructure and integration buildings. It's a manual for all the integration buildings for the Apollo program, and I do like my integration facilities. Interstellar Space Shuttle? No. Speaking of Space Shuttle, I finally got my hands on the Lego STS. Cool. How's the build coming along, Sile? It's coming along okay. Alright. Let's build some landing legs. Or at least let's figure out a solution here for some landing legs. Alright, so we'll do landing legs, the reaction control systems on the first stage, and we'll do landing legs, RCS, and then control surfaces. We'll put in base stuff, and then we'll take the rocket for a spin after all that. We'll test everything. So, okay. So this is what I have right now. I need some telescoping system here. So what we need to do, the first thing that I really need to do is establish the fuel load. What's the fuel load that we'll be looking at? Where is our fuel divvied up? Well, I want the rocket to be able to mimic having like an oxidizer in a fuel tank. So with this, let's just empty all the fuel out of it first. I'll show you what I want to do. With real rockets, right? You have two, ideally, I mean, in a bipropellant rocket, you have two fuel tanks here. And I say two fuel tanks, like, I shouldn't say fuel tanks. You have two tanks. You have an oxidizer, and then you have a liquid fuel tank. The reason why is because rockets go up into space where there's no oxygen. You need oxygen for the rocket to work correctly, to combust. There's no oxygen in space, so rockets bring the oxygen with them in the form of liquid oxygen. A lot of rockets do. Some rockets don't use liquid oxygen as an oxidizer. You can use all kinds of stuff. You could use chlorine as an oxidizer if you really wanted to. If you have an alcohol chlorine rocket, do not go screwing around with that, please. Please. I don't want to be the reason why you lose digits. Why you're losing fingers. You could use anything, but generally with most orbital class rockets, it's usually liquid oxygen. The only other thing I can really think of that it could be is nitrogen tetroxide or dinitrogen tetroxide, which is the hypergolic propellant. You could use whatever. There's a bunch of different things. But generally for Falcon 9, Atlas 5, Delta 4, Soyuz, Angara, they all use liquid oxygen for all the big boy rockets, because liquid oxygen gives you a really energetic well, not energetic. You know, you have to combine the oxidizer chemically with things, but liquid oxygen generally is the most widely used, because when you combine that with any type of liquid fuel, you get a really nice explosion. Oxygen makes stuff blow up real good. I know that was a bad sentence. I understand. So, we have 6 tanks here, and now the reason why I made this a bunch of segmented tanks on the first stage is, believe it or not, for strength. I have these tanks slightly overlapping, and the reason why I have them slightly overlapped is because they're strutted together. This basically turns the rocket core into a gigantic, it's a gigantic strutathon in here. And that basically mimics the properties of an ISO grid. How they make modern rockets, they mill in stringers right in. This is my way of mimicking that structure by using a bunch of segmented tanks together like this. Now, I have 6 tanks here, and each, well, actually, technically it's 12, because each one has a liquid fuel and an oxidizer tank, but we can still get it to drain correctly. I was driving back to work when I commented trying MATLAB, then immediately lost the stream. Thoughts on learning MATLAB? I could do it. Actually, the MathWorks headquarters is not far. That's just, that's out near where I used to work, Jared. Yeah. MathWorks, the people that kind of came up with MATLAB, their campus is over in Natick. It's a little ways away from me, but yeah. That would be pretty cool. I think those are the guys that invented MATLAB. I forget, but yeah, I could do it. I could do it. I'm not afraid of learning how to code. I could do that. All right, so the reason why I'm making a big deal out of propellant balance and load, etc., is because I want the rocket to work like real life. So generally what you can do in KSP is you have this thing called flow priority. Flow priority basically tells you what tanks to drain first, and you can use that to get a certain result with your rocket. Now, that's MATLAB Fullwood? Yeah, their world headquarters is down the street. It's actually like 10 miles that way. And don't get me wrong, 10 miles in Boston terms might as well be 30 everywhere else in the country. It's a long way away for me. That would take forever to get out there because traffic is like that. But yeah. Anyway, so I'm thinking, I mean, what type of propellant? Carolox for our first stage would probably be better. Now, don't get me wrong, you don't get to choose what propellants. There's just liquid fuel and oxidizer in KSP for all the rocket engines. You have one type of fuel. You could mod in other types of fuel if you really want to, but I'm not going to do that. What I'm trying to do is I want to mimic an oxidizer tank, and I want to mimic a liquid fuel tank. So we need to think how long these tanks are going to be. I have 6 tanks total, and I'm gonna say let's go with 4 of the tanks being the oxidizer tank, and then 2 of the tanks being the liquid fuel tank. The reason why I want this is the reason why I wanted to do this is because I need the center of mass of the vehicle to be down here somewhere. Now, when the vehicle's empty, it is down there. Ideally, I want where the legs are pushing up on to be right at the center of mass. It'll help stabilize the vehicle. Because if the center of mass was up here, or if it was right here, when we go to land, it would be very easy for this thing to tip. Okay? So we want to get it like right around here. So how do we do that? Let's screw with our flow priority here. So let's say we have that. Let's fill up all the tanks. Now, don't get me wrong. When we fill up all the tanks, the rocket should never land on a full tank of gas. It really shouldn't. That would be a very bad thing to do. You really want to make your landing legs, because mass is such a big deal with rockets, you really want to make your landing legs be only really able to hold up the rocket when it's like at maybe a less than like an eighth of a tank of gas, so to speak, right? So this is where the center of mass is on the first stage when we're full. This is the center of gravity when the thing's full of fuel. So I want it to be right there. See the shift? That's a big shift. So obviously we're not going to land on a full tank of gas. So let's take this tank and set that to flow priority 9. Setting this number higher is going to make the tanks drain quicker. Actually, I'm gonna get this zeroed. So we'll set the tank priority to 1. For some reason, it assigned a negative number. Let's just get all of our tank priorities to 0 first, and then we'll go from there. Okay, so we would want, because there's 4 oxidizer tanks, right? Let's just mark them as orange right now, just because. Those are my liquid fuel tanks. Once again, they're not. These will carry liquid fuel and oxidizer, and so will those. But I'm segmenting and changing the drain priority to get them to match the characteristics of a real rocket, so it's easier to land the thing. Now, the best way to do this, honestly, would just be to drain 1, 2, 3, 4, 5, and 6. Because if we did that, right? Right, we drain all these tanks, right? And then that tank is the last one full, right? See that? That would be really good. That's really stable. But as we drain, look what happens. Our center of mass ends up shifting back, and then it goes forward. I don't want that, because that could make it potentially unstable, especially when we're running out of fuel to land. Like if we get down here and we still haven't landed, my center of mass is actually shifting upwards. That's not good. You don't want that. I mean, it's not going to make that big of a deal, but even compensating for that little bit could be the difference between the thing tipping over and not tipping over. I don't want this thing to be very, very stable right up until the point when it lands, and then have the center of mass move up and have it pendulum. Because like if we're coming in kind of sideways and that center of mass moves up, it could be the difference between us tipping over. Now, it could lure you into kind of like a false sense of security, I guess. I know from experience. So I don't want this center of mass to go below and come back up. We only want it to move down in one direction. The rocket will be more predictable this way. So let's say we drain that tank and then we drain this tank. Let's see. Let's just fill up all the tanks first. And we got to get our fuel to flow proportionately here. So, hey, Merry Christmas. What is that, Vulcan? Oh, nice picture, man. She's a beaut. Two to one, Rocket Guy. Bingo. Hi, by the way. How you doing? How's your weekend? Now, Rocket Guy, how are we going to do this? I mean, 2 to 1 would be Keralox, right? That's about right for kerosene and liquid oxygen. I mean, obviously it's not going to be exactly right, like, because we don't have to worry about mixture or anything in this game. So let's see where... Oh, that tank is empty. All right, I'm going to get a flag out here, and we'll get a 375 flag. And we'll put that 375 flag right here. What's VSR3 mean? And I'm going to basically align that. I'm going to align that flag with my center of mass. And then we'll set the flag as just a checkerboard marker. I use these. Predominant actually made these. A viewer in chat, Graham Weldon in chat, made these. And they're very, very useful for like doing different marks. Actually, I like using the flat flags because it's really easy to see stuff, and they're small enough to not look like anything crazy. Seed Weldon. I wish I could say relaxing, but no such thing. But regardless of me burning the candle at both ends, things are really great. There's nothing wrong with burning the candle at both ends as long as it's for a purpose. And Rocket, I know you're smart enough to know that it's for a purpose, obviously. Alright, so let's move this into position like that. And go right here like this. Set flag. Okay, so that's our center of gravity with a full tank of gas. That's not necessarily going to be completely useful information for landing. The whole point is trying to see how far the center of mass moves. So, if I set tank priority 1 here to that... Hey, Hokey! 5 subs. Thanks, guys. You guys have been really good to me today. I really appreciate it. Thank you. All right, so let's see. If we set that 2 to 1, right? Let's go here like that. Go here like that. And then go here like that. Okay. That's pretty good. That's a pretty big deviation, because remember, we're draining more from the top than we are from the bottom. So, remember, we want to try to get this so this thing doesn't go down and then back up. So now how would we do this? We have one oxidizer tank down here, and we have this. So let's set all these tanks to half, and let's see what happens. Oh, see? See, she went... Actually, hold on. Let's mark that position here real quick. Make sure that tank, and that tank are empty. Actually, you know what, fellas? I'll make this a little bit easier for everybody. B. I'll mark the tanks for you guys. One. Yeah, the number flag packs really help too. That's another thing that Predominant made. If you guys want the number flag packs, type the number flag packs. Type exclamation point flags in chat and it'll grab it. Juan, see? Okay, so all right. So now I'm going to put the priority number under each one of these tanks right here. This is flow priority down here. Try to make this pretty easy to look at. So this is set to flow priority 1. So these tanks are going to drain first. And when they drain first, that's where our center of mass ends up. So let's take another marker. Let's give ourselves an approximate here. Okay. So, what I'm going to do is I'm going to set some numbers here. So, let's take the flat flag, right? So, and let's have our full tank of gas be set as position 0, right? That's position 0. So that means we're full, okay? Or initial mass, right? Then, this is after flow priority 1. So this is basically when we're at a half tank of gas. And we'll set that to mark with the priority number. Why is it upside down? Right? Did you get the MLV flag I put in Discord? I didn't, AP. Where'd you put it in Discord, man? I'm not sure. If it all drains equally, what would cause the center of mass to go up? If it all drains equally, our center of mass stays like up here material. That actually might be the right way. I'm not sure what the right way is. I'm trying to figure it out. I want this thing to drain fuel like a real rocket would. Because if we do that, we're going to get more realistic flight characteristics. I actually should take the legs off for this test, but it's okay having something there. We need something representative of the legs, right? We're gonna have to redo these numbers when I finalize the leg, just to see what happens. Alright, so now if I set all these tanks to half, right? $16.20, $16.20, $16.20. Okay, she's gonna move backwards just a little bit. Now, if we set these tanks down here, oh boy. 648. So set it to 648, 648. Yep. Okay. And now let's just set it to nothing. Let's see what happens. Bingo. Okay. Set that. Okay, so down here, these numbers show flow priority. These show the number of the tanks, and these are our mass positions. So this is our final mass over here. So if I take this and we move that there, let's try to get it lined up on an isometric view. Or semi-isometric, I suppose. Now, I know this kind of seems like, well, okay, what is this proving? Well, this is going to give us an approximate area where we would want the legs to be, give or take. We're going to have to fine-tune it, but that gives us exactly what we're looking for. So down here, we have tank priority. 1 is going to drain first, 2 is going to drain second. And I think that gives us really good flow priority. Basically, I'm going to tell it to drain the fuel in a more realistic way to a real rocket, and that gives us a slow and gradual movement down. Does Falcon 9 have the same issue where the center of mass moves up at the very end? No. No. Center of mass is always going down on Falcon 9. No, no. Alright, Alex, have a safe flight, buddy. Dude, we're gonna be in almost the same time zone. You'll be able to watch way more of the stream. Okay. Alright. So. And this is just the MLV. There's no cargo. Yeah, this is just the first stage on the MLV, dude. Yeah. I have a fairing design for it. A fairing and a second stage design. But dialing in the first stage is super important. The reason why it's super important is because this is designed, well, it's literally designed to do more than the second stage. The second stage just turns the engine on up into space. I mean, don't get me wrong, we're going to have to do more than that. And then the payload and the payload fairing up at the top, it's pretty straightforward stuff. You know, it's weird because you gotta kind of design rockets from the first stage up. And in Kerbal, you design them from the payload down. In real life, I'm not... Well, I was about to say in real life they don't do that. No, that's not exactly true. You design the thing as a whole, to be honest. But, yeah, that's pretty much what I'll do. But because the first stage does more, we need to spend a little bit more time on it because it comes back down and lands. So, yeah, we're basically coming up with landing numbers and masses here for this right now. Okay. So we don't need the color indicators anymore. We can set it back to the black and white scheme. Okay, so that's give or take where we need the landing legs to be. Give or take. So we're going to need to... What I'm going to do is we're going to just move these up just a little bit. And see, moving them up just a little bit did screw with the masses. Just a little bit. But that's fine. That's okay. It didn't do it that much. That's pretty much inconsequential. Okay. Cool. Now that we have these, our initial positions, right? We probably should have done this without the landing legs so I could show you the exact deviation. So you know what I'm going to do? I'm going to take them off. This was just a... Honestly, I can remake that in 2 seconds. That was just a placeholder design. Let's just mess with them without the rocket, without the landing legs attached. So we could do this kind of backwards here. And once again, it's just going to be an adjustment on the flags. Alright, so now let's fill that tank up. Fill any tank that has the bottom number marked as 2. There. And yeah, these should be about the same shift forward and backwards for the most part. The reason why I use the checker is because I try to line up the checkers of the flag with the checkers of the center of mass indicator. It basically is a gun sight, so I can make sure that the camera is lined up so I get the exact spot. That's why I use these checker indicators. May I post the link? Sure, AP. You like the orange better? Really? MLV logo. Oh, that Discord link isn't working. It's trying to link me to the thread. AP, what channel did you put it in the Discord? Just tell me the channel. I'll go find it. Keep the 2 lower tanks white. Oh. I don't mind it, dude. That's actually pretty cool. Can you tighten up the V shape and make it look pointed like the M? If you do that, dude, I'll put this on the side of the vehicle. Keep in mind, MLV is a placeholder name. I'm not just gonna make the MLV and then when I put it on the pad, I'm gonna call it the Mega Medium Launch Vehicle. No, it'll have a name. It'll have a name, like Condor or Collins or Neptune or something like that. MLV is just its placeholder name for now. I do like it though. That's pretty cool. And I will put this on. I will put it on the side of the vehicle. If yeah, just make sure you give me it in flag form. Yeah, exactly, Blue. Yeah. All right. So there's our initial, halfway, and final. Note that because it's 2-to-1, right? And because the rocket center of mass when it's dry is down here because the engines, spoiler alert, the engines are way heavier than just an interstage up at the top, right? Because of this, the distance that it moves between tank draining gets smaller and smaller over time as the center of mass moves closer to this side. So there's our final mass area right there. Alright. Cool. So let's save that. Now, with whatever landing leg that we build, this should, with whatever landing leg we build, it should actually end up moving this way a little bit. So, it's good to have these numbers and these positions when, it's good to have these numbers in positions now. I should have done it this way the first time without the landing legs being there. What genius at NASA thought that was a good idea? I don't know, Blue. I don't know why NASA has this incessant need to dumb everything down and explain it to children. Like, implying that children are too stupid to understand what a rocket does, which is... Alright, but whatever. I mean, whatever they're doing, it clearly works because people like NASA, you know. But I mean, it's a personal opinion. I think that you want to know the best way to get people involved. Don't call your rocket Mega Moon rocket. You want to know we want to know what really gets people into STEM? Launching things. Why do you think people so vehemently defend what SpaceX does? Because they launch stuff into space. Because they're getting stuff done, and they look really cool while they're doing it. As we start getting into SLS operational missions, I've been very vocal about this. The SLS needs to do stuff like that. You can't sit there and just call it a Mega Moon rocket while it's rolling back and forth from the pad for wet dress rehearsal. SLS needs a name that's not an acronym. It needs a name that's not an acronym, and you got to launch the dang thing. But I fully understand that that's something that takes time. That's why, hence, as we move into operational missions. It's just rocket science. Alright, so let's build out a landing leg. We gotta make sure that we don't intrude on the hold down points here. Alright, nor the umbilical attachment point right there as well. That's where I fuel up the thing when it's on the pad. I think Ares 4 would be a perfect name for SLS, personally. And Jupiter is kind of meh. Ares 4 would be fine, because what a lot of people don't know is that SLS, and I had people that work on SLS tell me this.
Discovery, go
SLS is basically Ares 5. It's Ares 5, or what Ares 5 was basically going to be. Through the design changes on Ares 5, they basically figured out that it would be better to use shuttle engines with it because of the heat. Not because of human rating or anything, but Ares 5 probably would have ended up having 4 shuttle engines in it. Just because those RS-25s have, they have cooling. They have, not regenerative cooling, they run the propellants through that engine nozzle first to keep it cool. And the reason why that's a problem is because, as opposed to the space shuttle where you have your 3 engines over here and you have 2 SRBs here, with Ares 5, they were going to take RS-68s and put them here, surrounded by solid rocket boosters. There's a lot of heat convection that happens out there, and the outsides of the rocket engines can actually get damaged because you clustered so many rocket engines together. That's something that Kerbal doesn't teach you. Clustering rocket engines together can make it so it can melt the inside of the outside of the rocket engines because they're so close to each other. They radiate, or they convect so much freaking heat off the side that the heat radiating between the engines can actually melt them from the outside, which is why the Saturn V engines, if you go and watch a Saturn V liftoff again, if you look at the F1 engines, they're wrapped in asbestos. That was their solution because that's what worked. Yeah, Phil, I know. Saturn VI? Maybe. Hey, I'm 21-month resub. Yeah, exactly, Floating. That makes it even crazier that they can cluster so many Raptors together and not have to worry about that. That should go to show you the cooling challenge that they had to deal with putting 33 of those things next to each other. It's really kind of crazy. Anyway, all right, so let's think about this now. How do we want this landing leg to work? I was thinking a telescoping landing leg would be fine. But there's things that we have to think about here, guys. If we have a telescoping landing leg, now here's where we're gonna get into some Kerbal hierarchy stuff, okay? My favorite. The easy solution would be to just put a telescoping hydraulic here and put it there and call it a day. There you go, we're done. Well, that doesn't reach far enough, so I guess we could stack them if we really wanted to, like that. And that could get me what I'm looking for, right? But there's something we're not taking into account here. Rockets have different spots where they like to be grabbed from. Ha 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 ha. No, seriously. There's integration points on rockets in certain areas for a reason. Okay? Namely the hold down points. The hold down points on a rocket are the strongest structural points on the rocket by a long shot. Why? Because they have to A, be able to hold the entire fully fueled rocket first stage, second stage payload, right, onto the pad. And they also need to be able to hold this thing in position at full thrust for a second. That is the strongest structural piece of the rocket. If I attach my landing legs up here, we're attaching to a less structurally sound part of the rocket than this. And when I say structurally sound, that's what I mean. I made this thing very strong on purpose. Because that exact reason. This is the part that's going to get crunched the most. So, putting the landing legs here and mounting them up there is something that we could do. It's possible. But we'd be pushing up structurally on a spot that's not really designed for it. I didn't really intend for that to happen that way. So, and this is something that I really didn't take into account. The ideal thing would be to have something that attaches to this fairing right here. Because that fairing is part of the it's part of the engine section of the rocket. Attaching to the fairing would be really strong because I have a lot of stuff attached to that fairing and it's all strutted into position, right? So, it's a very sturdy boy, indeed. So now that I'm looking at this, I'm not entirely sure that telescoping legs would be a smart idea. But, let's look at something that has a similar landing leg to this. Let's look at Hoppy. Why not? How does Hoppy do it? That has a similar type of landing leg. How does it do it? Let's go in here. Well, look. They have the top of the landing leg attached on where a bulkhead would be. And then they have another thing attached to the engine section, the thrust structure. See what I'm talking about? And then they have lateral stabilizer bars there. How do we do that? How do we make this? Interesting. How would we make that telescoping? How would we make that retractable? I'm thinking. Okay. How did the LEM do it? We know the landing legs on that LEM folded up. They folded up to fit inside of the S4B. Like that. Alright. I think I got something. Okay, so... what if we had something like this, okay? And then this thing moves down into position like that, right? These are landing legs, but they're landing legs that are braced with a strut. Right, so we'd have, let me just prototype this out. We put it in 4 times symmetry like this. Now, a landing leg like this isn't going to be that stable. You're going to need a strut to hold it in position, like this one. Now, what would this thing look like in a folded position? What would it look like when it's up like this? Because these landing legs are going to have to do something like that, right? Oh, that gets complicated very quickly. Wouldn't you want the strut to telescope? This thing, yeah, it would... yeah, it would do something like that. Right? And then we could cover this with a nacelle. But, see, like, when this thing is in the upright position, this thing would have to also be able to hinge and move like that. Right, and then when this thing moves into the, like, 45 position, this thing would have to come back in like this and... Interesting. I mean, I like this. This looks really nice. That would be very strong. But this runs into the same problems that we had when we tried to make the SpaceX style landing legs. It's the exact same thing. You're running into the same issue. Yeah, we'd have to get these things to lock out on landing. Ooh. B-roll rollout stuff. Yes, very nice. RT, I'm good. How are you? Yeah, very good. See, this way we have structure attached to this, right? Oh, boy. Yeah, Grav, we would need to get this thing to lock. That would have to lock out. It would have to lock out right there. Now, we could hybrid tech this whole thing up, right? And I could hybrid tech that, and then we could put a hybrid tech hinge here. A couple of things, though. This hybrid tech hinge is dangerously close to the ground. You don't want to land too hard and break that, because if you break that, it falls over. Right? We don't want that. That's not really good. All right. Let's try doing some offsetting here. So this is the problem that I had with this before was getting these hinges to lock out correctly, right? They weren't locking out correctly. Let's try doing something like this. Give me an I-beam here, like that, and not in 6x symmetry. And say we had this set up like this, and it was like that in the initial position, right? Hinge to the middle of the legs and make the support free floating, or does KSP not like tensile structures? Hinge to the middle of the legs and make the support free floating. I could do that. That's not going to hold up anything. It never occurred to me to put two pistons attached to each other. You're so smart. Thanks, man. It's just something yeah. Something that came from a purely on need thing, Mammon. But yeah, thanks, man. Appreciate it. So, Mammon, here's what I need to do if I need something with a longer throw than 5 meters. Watch. Here's a cool thing that you can do. So take a cow controller, right? Attach that to one, and then take another one of these things, detach the cow controller, watch. And then do something like this. So take the second one, and then I rotate it offset 5 degrees, and then go into the cow controller, open this up, leg throw, right? Take this, attach that, and attach that. Actually, hold on. We won't do this in 4 times symmetry because the game will get confused. Target extension, target extension. Then we go into the cow controller, set them to maximum extension. We can copy that. So that means as the cow controller plays, it'll extend more, right? Now, this is all fine and dandy, but this makes these things hard to stow. They're hard to put into position. So what I do is, and this is the reason why I ticked it off 5 degrees, I do that. Now, don't get me wrong, this doesn't get you as long of a throw. This isn't going to get you a 10-meter throw because you clip the legs into each other, but it is a good way to make just basically one piston that can throw a lot longer and still look compact enough to work correctly. It's basically a telescoping hinge, or a telescoping, it's telescoping. That's how telescoping works. You have one inside the other. Yeah, this is how I make cables for cranes and stuff. This might end up being how we have to do this, right? And, you know, if you need to select individual things because it's offset 5 degrees, you can put your mouse in the right spot and get it to place correctly. But see, we're running into the same problem with this design. We're running into the same problem that we were running into before.
Discovery,
Hey, Shaxter. What's up, man? The problem that we ran into before is when these legs get into the downward position like this, I need to be able to lock this hydraulic. The reason why I need to be able to, or not lock the hydraulic, I need to be able to lock this hinge. If we don't lock the hinge, the entire load of the rocket is going to be placed on this thing. And don't get me wrong, That's not that big of a deal. However, if we lock it and then I auto strut this to say like heaviest part or something, when this is in the locked out position, it'll strut back, especially if I set it to root or something, it'll strut back up there. See that? And that'll make it extremely strong. This will basically work like a locking collet. So it won't move. And then that coupled with these things holding it up, should make this thing really, really strong. Oh yeah, Josh, yeah, cal overclocking. Yeah, very, very fun. It's just getting this damn thing to lock into position. Does it damage the engines? Does what damage the engines? When did KSP add the orange paint? You can set the tank style. They added that with making history, dude. What about RJ's grip pad thing? I don't like putting grip pads on the, I don't like putting grip pads on here. I find that an I-beam will stick to the ground really nicely. So like when this thing comes down and in, right? That's super strong right there. This should be very, 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 very strong. It would be better to use 2 points of contact to the structural engine section. Well, with the hybrid tech, Neo, I'll be able to... This will... Here, I'll show you. The landing legs are going to look more like this. They'll look more like that. They'll be triangulated. That's just there to give you kind of a representation. So we'll end up having something... Here, what does this look like in the up position? Ooh. Yeah, see, this is what makes SpaceX's freaking landing legs so smart. We're talking something like this. And then, like they'll fold out like this. But see, once again, if we don't get this thing to lock out, if we don't get the hinges to lock out before... If we don't get the hinges to lock out before, I don't think this is going to hold anything up, you know? That's just kind of a little bit of a weird representation. How do we get them to lock? Yeah, Josh. Yeah, hybrid tech. Yeah, we figured out a way to action group same vessel collision on physicsless parts, dude. Yep. You know what? I like this design over the Falcon 9 style design, just because when the Falcon 9 style design opened up, it's very... These have to be, like, extremely strong. They have to be able to hold that thing up. Oh, we're going to have to do some hinge testing. Use Fred. I don't know if that helps. Okay, guys. I gotta do some hinge testing. We gotta figure out a hybrid tech hinge that's really strong. I like these telescoping landing legs. The telescoping landing legs will work. But I think in order to get the most structure from this, we're gonna need a little landing leg here. I'm basically gonna make an animatable version of Starhopper's legs. This is what I want it to look like. I think this would be good. Only this part is hinged, right? And then that's telescoping. So the landing legs will fold out. Fred lives on in your heart forever. Yeah, Fred, that was a cool solution. I think this is the right way to do this. So... we could just sit here and develop them right on this thing. It would be a little bit difficult to do, but I think we can do it. I'm going to need to make hybrid tech hinges that can hold this thing. Okay. Yeah, I like this idea. Let's do this. I like this animatable hinge better. We're still going to have to worry about locking that damn controller out. That's going to be really hard. But even if that controller doesn't lock out, as long as I make it so most of the force is getting pushed onto this thing, and some of it gets pushed onto that thing, coupled with the angles that we're working with here, I don't think when we go to land, these legs will flip back up. I really don't. They won't flip back up. We could lock the hydraulic cylinders instead. If I lock these into position, then that doesn't matter. That doesn't matter if that's locked out or not. Oh, that's so smart. That's so much smarter than what I was doing. Okay. 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 And how much force do these things have? The 3PT telescoping is 800, I think. It's 800 kilonewtons out of the box. So how much thrust? What's our TWR right here? How much does the skipper have? 650. So if I take the thrust limiter on this and go like that, our TWR is 0.80 with 650, which means if I have 800 kilonewtons of thrust, which would be something like that, what's 10% of 650? Oops. Okay, so we have 650 plus 65 times 6. That's 1,000. Okay. $845. The reason why I'm testing this is because I'm looking to see what the TWR is here. See? TWR 1.19. If our force here from these legs is higher, these are 800 kilonewtons, but then again we are at a little bit of a cosine loss of force there. We may have to overclock. How much fuel did I load into that thing? 4 tons. Yeah, I'm not sure that these things will hold it up. We might have to overclock these a little bit, but that's okay. That's okay. We can do that. If I can overclock them and get them to hold this thing up without locking them into place, it'll work. And then if I lock them into place, it'll work even better. We got to be careful though. We're going to get drift here because these are going to hold this thing up. It's going to drift it. And I'm not exactly sure how we get it to not do that. We're going to get drift in between first and second piston here. Interesting. Interesting. How am I going to fix that? Placing pistons in between Kraken bearings. Okay, yeah, I see what you're saying. Might have to measure the wear and tear on this thing, Hellfish, over time. Let's just design it without it. I have a ball in a cup solution for this thing that should work. It should work. But it's a lot of parts, so I'll hold off on it. This thing shouldn't drift too much. And because the maximum throw is nowhere near maximum extension for this, it might be okay over time. We're just going to have to test. We're going to have to test with it. We're going to have to test with it and see. But that's okay. That's fine. Okay. All right, fellas. Let's build. So, let's think about this. The first thing that I really need to do is I need to make a hinge that's strong enough to hold things. Now, the strongest hinge that we had was the spectrometer bearing. That was the strongest one. The one where we make the bushing for it out of the spectrometers. And the reason why that works so well is because those have a very thick collider box comparatively to the thermometers. Stuff likes to ride out of the thermometers. But the thing is that these things are gigantic and making a hinge there wouldn't really work too well. Hey, Dutch guy, thanks for the raid, dude. Much appreciated. Hey, Tabamari, what's going on? Okay.
Discovery.
16-month resub. Hey, thanks, man. Welcome back. Where have you been? Hope everything is good. Hey, Bormas, what's up, dude? How are you? Okay. All right. Let's get our initial pivot points here. So let me go back into robotics, and I think we can use alligator hinges here. Somebody suggested doing this with the other design, and I said I didn't want to because I thought it wouldn't be compact enough, but we should be able to get away with it with this design. What I have to see, and I have to be absolutely sure, is that if I absolute snap something, that it snaps to the pivot point. If it doesn't, then we can't use this.
Discovery. Go at throttle
I
up.
think we're in business. All right, cool. Get rid of that, get rid of that, get rid of that. All right, let's start over again. Grab another one. These alligator hinges should be a lot stronger than the other hinges. But see, the thing is, the reason why I was trying to use the G00 hinges is because these ones are compact. It's compact and it's less mass. But then again, I did factor in a good amount for these, so Juicy J, 4-month resub. Thanks, guys. And Dutch Guy, thank you for the raid. Back to Kraken Tech. No, not Kraken Tech. Hybrid Tech. Differences. I've missed the EJ KSP Engineering. Been working hard, saving monies. You know the score. Oh, yeah. Yep. Yeah, I know how it is, man. Oh, yeah. That's the hustle. Just got to keep going. Okay, so let's build this out. How do we want to make this? Okay, so let me go and grab the thermo bearings. We're going to need those. Dutch Guy, what's up with you? Were you playing Kerbal as well? Alright, so how do we want this connected? I want this connected to a hard part here. So a hard part that goes before this. So let's get a cubic octag, right? Well, actually that's probably not a good idea. But if we strut that thing, then it should be okay. I'm trying to build out the hierarchy in my head, fellas. I want, for this hybrid tech stuff, I want something that attaches. So we need two parts, okay? The first part that we need, right, is something to attach the hinges to. We need to attach the outer hinge to something. And then I can take another RCS, right? Get rid of the thermometers. Then I need to go in here like this. And we need to attach that to the animatable part of this. So that means when we go to do this, see what it's doing? That acts like a hinge. And that makes this so this thing doesn't bend around and stuff. It doesn't play any games. Well, it still kind of does. But see what I'm doing there? See the RCS ball? That's hybrid tech. This strengthens the hinge. I use gliders from parts in games to strengthen this thing up. But in order to do that, you want to really put the housing for it not attached to the robotic. That makes this thing ultra strong. Miss Pinter is here. Hi, Midge. How are you doing? Yeah, Tabamery, this is hybrid tech. Half Kraken tech, half robotics. All the plus sides of robotics and all the strength of Kraken tech all in one. This is my new hotness, dude. This is what I've been messing with in KSP lately. And the potential here is insane. Like, literally change the way we play KSP insane. See? Hybrid tech, man. We found a way to get physics-less parts to have same vessel interaction. And oh man, does it make stuff strong. Midge, how are you? You still stateside? Still stateside. Still states. Are you over here or over there? I'm flying back tomorrow. Cool. Alright, so alright. I'm not sure if attaching this whole thing to a cubic octag is smart, because a cubic octag is not very strong. I would have to strut it, and that's more parts. Not necessarily sure I want to do that. So what other part could we strut it to that's extremely strong? Do we have any open attachment points in here? We do. Midge is like, I gotta English all the time. But can you English well, Midge? That's the real answer. When do you think this rocket will be finished? I would want to get it done sooner rather than later, DB, but I'm taking 6 months off from KSP I just want to make sure that my engineering is up to snuff to go back into playing mission mode. Because if I tried to play mission mode right now, I would fail miserably. I gotta get back into the groove of things. Consider this like workout training and stuff. We're exercising this muscle up here. Indubitably. The rocket will never be finished. It'll be finished when you stop being a smart butt in chat, Taradra. Oh, wait, that's never happening. So you're right, I guess. So never? Yeah. Can we... You can auto-strut grip pads, but I'm not sure how well that's going to work. Hey, Neslick, I'm doing alright. How are you? Need to get tested for the plague for your flight? Yeah. Yeah, King, that'd be cool. Well, that's good, Midge. It's a 14-hour flight to Radra. Actually, it might be more from where Midge is. It was 14 hours from Boston. I've made that flight before. I ran out of things to do, and I watched the Avengers like 6 times in a row because I ran out of things to do. Midge knows. She knows. Okay, let's try this with a physics-less part. Let's try this with cubic octags. I'm interested to see what happens. So, let's just make one landing leg for now, and we'll see where it goes. And 43 Fahrenheit up in the Great White North. It's too hot for this Inuit. Oh no. Yeah, that's a heat wave for you. It's gonna melt the damn igloo, man. I think you will like this. What's that, W? Haha, look at that. You found out there's an abandoned missile site near your house. What state are you in, Funky Flex? I can tell you what type of missile site it is. California. Titan 1. It's not an abandoned missile site. It's an abandoned launch complex. Yeah. Are you in the valley? Not valley. The valley, Funky Flex, that runs from like Bakersfield to Fresno up to Sacramento. I don't know what that valley's called. I totally forget. Yeah, there's a bunch of Titan 1 missile bases all around there from like Bakersfield all the way up to Sacramento. Yeah, Titan 1, right? It's a big mother. Titan 1s are cool, because check this out. Titan 1 missile silos weren't just silos. It's not just like a silo with a control center like a Titan 2. They were literally an underground launch complex. 3 pads. They're gnarly cool, dude. Yeah, Titan 2 is just that. It's just a missile. You have your access portal, blast lock, and then you have your control center, and that's it. But because Titan 1s were Carolocks, right? You needed much more infrastructure. You needed infrastructure to keep the locks cool and stuff, and you needed entire propellant farms underground. It's actually, I mean, don't get me wrong, Titan 2 had that as well. But yeah, it's an entire launch complex, dude. Yeah, I'm fairly positive the missile site that's near you is Titan 1. If it's not Titan 1, that means you're near Vandenberg, and it could be anything, you know? But yeah, Titan 1s are entire complexes built underground. They're, like, this is the closest that we ever got to a Fallout vault, because that's basically what it is. It's a Fallout vault with missile silos attached to it. These domes right here, for the control center, and for the generator are insane. They're huge. Like hockey rink big. Like I said, that's the closest thing we've gotten to a vault in real life. Oh, you have Nike missiles. Oh, they're not that cool then. Nike missile sites are still neat, but yeah. Nikes were everywhere, dude. That's an interception. That's an anti-ballistic missile. It's an ABM. It's not an ICBM. Yeah, I have Nike sites near me as well, which is cool. They put them everywhere. Coastal defense. Yeah, Samurai, they're all over the place in Massachusetts, too. There was a former Nike missile site in, Wayland, I think? That's a little ways west of me. They had a Nike missile site there to defend the Raytheon plant that was there that made Sidewinder missiles. Yeah, kind of, you probably want to defend that. Yeah, and these Titan 1 missile sites would get obliterated by a nuke. As cool as they are, they're not deep enough into the ground. Yeah. The reason why is because a silo has to be near the ground, because there's that whole thing with what it's supposed to do. That needs to be near the surface. So yeah, this would not do well in a nuclear attack. If this thing gets direct hit, there's gonna be nothing but a crater there. But like I said, it's the closest thing we ever got to a vault. It's really freaking cool. They're really cool. There's a bunch of these Titan 1 sites around. Nike missile sites are cool too. Here.
Discovery, go and throttle up.
Nike missile sites are basically the Nike missiles are on a transporter erector, a TE, like that. See? And they pop out of a bunker. They're all horizontal, right? And then there's a bunch of launch pads right next to each other, and then the doors open in 1, 2, 3, 4. They pop out like that. Nike sites are really cool. They're really neat. They're not as cool as Titans, but that's still pretty neat. Yeah, see? There's the door. The door would, and then the TE would pop out and see ya. They're pretty cool. They needed to be deployed really, really fast. Because, like I said, they're an ABM. These are designed to hit missiles, hit incoming missiles. This is a defensive weapon. And it goes really, really fast. I don't know if you could tell by the strakes on this thing. It goes very quickly. Yeah, really freaking cool. Yeah, see? That's freaking legit, dude. That's really, really neat. It's a really cool piece of launch infrastructure. You know, sometimes I have to remind myself, like I look at these and I look at Titan 1 sites, and the Titan 1 and Titan 2 missile silos are just like in the middle of cities and stuff. They're in the middle of cities, or they're like right off of a highway, or, you know, they're out in the farms and stuff. And I'm like, my brain goes, man, they put a launch pad right there. Why do we have to launch near the coast? That's the dumbest thing I've ever heard. They clearly have no problem launching like right next to people. Are rockets really not that safe? And then I realized, well, if that launch site ever became active and we were launching a missile, I don't think worrying about damaging the surrounding terrain is really something that you would that would be high on your priorities list. And I went, oh yeah, yeah. That's why those launch sites are everywhere. Oh yeah, pretty sure you're gonna send it, and then one's gonna get sent back to you, and you could have launch sites wherever you want. It really doesn't matter because anything that's useful around is gonna get obliterated real quick. Yeah, if they launched, I don't think worrying about the farmland or the city around you would be a high priority, unfortunately. But yeah, fortunately that never happened. What's this, Allie? NASA to make rocket launches from Northern Territory in historic space-making moment for Australia. Cool. That's pretty neat. There may have been Sea Kraken, I don't know. I'm pretty sure Nike is an ABM, though. It's designed to hit incoming missiles. Like THAAD, or the Sprint missile. THAAD is really cool. Tori Bruno worked on that thing. But anyway, let's get back into leg design. Hey Vickers, what's going on, dude? Alright, let's pop in here and take a look. I'll try this mounted on a cubic octag, but I'm not sure how well that's gonna work. Is it not I'm misremembering. It might not be an ABM. It might be something different. I don't know my missiles too well, even to this day. I know my launch vehicles. Differences. This needs to be attached right here. And then this needs to be attached to the cubic octag to make sure that it's really strong. It's anti-aircraft? Yeah, there you go. Not much. Oh, could I shoot you a DM on Discord? I have something to say. It's better to burn out than fade away? Yeah, sure, of course. You guys can send me a message on Discord anytime. I don't care. I might not answer it right away, but I will answer it. There's a Nike standing on the side of some random road by you in Texas. Cool. Have you checked out Captain of Industry? No. I've been told about it though, Geek. Alright. Let's go in here like this, and then let's go here like that. Select that. Enable same vessel interaction. Select that one. Enable. Select the thermometers. Enable.
Discovery, go at throttle up.
39 months of Geek. I hit the thingy! Alright, we don't want any damping force from this. There we go. Okay. Let me think about this for a second. We really got to make sure we get the hierarchy right. Meaning I have to put this together in a certain way that I think is the strongest. And this is why the hinge piece, like the hinge housing here, I mean, I have to attach, like you have the socket and you have the hinge. I attach the socket not to the robotic, because the robotic's going to move around. Actually, it might be better to attach the hinge part to the part after the robotic. That might be the strongest way to do this. Because I've messed with this before. I've messed with attaching the socket to the bottom part of the hinge, and then the hinge to the moving part, right? And that will make a strong hinge, but they'll still drift around on this connection right here. So having another cubic octag up here like this, and then... Actually, we should do this in Mirror Sim. Yeah, that's not gonna work. Okay. Because I have the thing tilted 45 degrees, so we're gonna have to do it this way. We'll do it one by one. So take this piece, right? Move it like that. Okay. SpaceX tweet, what's up? Targeting Wednesday, June 18th for Nilesat 301 from Space Launch Complex 40. The launch window opens at 5:04. Weather is 60% favorable. Cool. Hey, N9. How are you? Alright, so. Oh, yeah. That should do it. So, what I'm going to do is move these into a position where it's a little less intrusive. Be able to mount landing leg parts here better. Okay, so do you ever find that your craft file becomes corrupt? It happens to me occasionally when I nest symmetries like what you're doing here. Is there any way to avoid that? Yeah, Mammon, build the thing out in symmetry and then remove from symmetry after the part has been placed. If you don't want to do that, sometimes you got to rely on symmetry for auto strutting and stuff, right? You might not be able to mess with it. What I find, if you notice, what I'm doing right now is I'm making one of the landing legs. I'm not making all 4 and 4x symmetry. This allows me to not lap symmetry over symmetry, like what you're saying. I only do that at the very end, after I'm done messing with everything. That's the most ideal way to do it. However, there is a way to freeze transforms like that. To freeze the symmetry transforms. You can reset them by doing this. Watch. So I take this piece, right? Let's do something like this. We're stuck in radial symmetry here. Let's go over here and switch it to mirror. And then we could switch this to mirror symmetry. No, we can't because it hates me. Yeah, the game also doesn't like stacking mirror on radial. It really, really hates it. So, right, you have symmetry here, and then, right, let's take something like this. Now we have double symmetry, right? You have double radial symmetry, or double mirror sim, right? If this is doing something that you don't want it to do, right? So, it's doing something you don't like. Take this, hit the reroute tool, reroute it to the part furthest down the hierarchy. And then, take it and reroute it back. Note it attached backwards. Did you see that? Because it reversed the flow, Mim, and I was telling you about this the other day. See what it did? It reversed it. Look at where it's attaching that I-beam. Comparatively to just a second ago when I attached it, it attached like this. And then this part was like that. Now when I go to attach it, it reversed it. We reversed the flow on the hierarchy, and now it's attaching to a weird spot because it flipped the part around when we rerouted. And now we don't have any symmetry nodes here. I can move this individually of the other one. See what I'm talking about? In 3D modeling, we just froze the transforms. We just deleted all the information that told that this was in symmetry. And we also reversed the hierarchy of it back to front. And reversing it back to front deletes symmetry nodes because you can't have symmetry nodes when that's your root part. This thing can't exist with a symmetry node because the symmetry node information is on that root part. And if that's your root part now, it deletes it. The game deletes it automatically. Yeah, you flip the hierarchy. Yeah, N9. Oh, yeah. Do you see what happened right there? You see how it's attaching differently? Here, I'll do it again, just in case. Just in case anybody wants to see what I'm talking about. So, let's just move that off to the side, right? So, This part attaches with this piece down, right? That's our root part of this subassembly. Now let's go into mirror sim. Let's go make that same thing, okay? Now I take this piece, double it. Now we have mirror sim on mirror symmetry. This might break it, see? That screwed it up because you're stacking symmetry nodes. So anytime you move something like this symmetry node right here, that mirror sim overrides this mirror sim. Game doesn't understand that. You can't stack symmetry nodes. And if you do, you have to make sure you leave it just like this. Now watch. So I can take this part off. If I take it off, right? I can still attach it. You can take it, put it out here, put it back, attach it, no problem. It always attaches like this. So now, go out here, hit the reroute tool, and reroute to something that's at the very end of the chain of I-beams, right there. Now, reroute back to this part. Now watch how this part attaches. The game literally flips the parts around 180 degrees. It's attaching from this side because when we rerouted it, right, that became the last part or not the last part, it became halfway through the chain instead of the first part because we went up here, 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 up here. Right? It went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And because this is just another part in the middle of the hierarchy, instead of the root part, it flipped it. Now it's downstream of the root part instead of being the root part. And now it attaches different. See? Oh yeah. This is why I say the Kraken is a false deity. Glory to the hierarchy. You understand why this happens? You can make anything incurable. Anything. Yeah. Understanding the hierarchy will allow you to be able to implement real-life concepts in Kerbal correctly and not have them freak out on you. Kraken heard that? I don't care. Kraken don't bother me. We've tamed the Kraken in here. I know what's going to piss it off and what isn't. Alright, so let's go back in here. Okay. So now that's the strong boy hinge, right? So now let's move it into the position that we want. Here's what I'm going to do. I'm going to do a little trick here, though. We got symmetry stacked on symmetry if I put this in 4 times. So I'm going to remove this, and I'm going to take this piece, and I will put this in 4 times symmetry. The reason why I'm going to do it is because this gives me a good place to mount this. Now, where do I want my landing legs pivoting? I'll put them in the same pivot spot that we put before. And check this out. I did not place these in symmetry. And because I didn't place them in symmetry, I should be able to move this, and all 4 of them should work just fine. It might screw up the thermometers, though. I'm not sure. Let's check. Nope. Because they're not placed symmetry on symmetry. I placed them one at a time, so when I go to make the landing legs, I can figure out the spread for this and not have an issue. Now, I'll take my cubic octag, and I'm going to move it down 1 tick, and that gets my landing legs into the most compacted position. Now, I didn't place those in symmetry either, and I didn't do that on purpose, so we don't run into that same problem, right? So now let's go in here like this, and so now I should be able to move these RCS balls into position, and shouldn't be a problem. But, oh wait, they're not lined up. What the hell? Why are they not lined up? Well, this is kind of a little bit of a different node, but they're not lined up because I didn't absolute snap this to part. It's just node snapped. The reason why I put the hinge socket, the reason why I put this cubic octag in first is so I have a mount point for the hinge now. So it's really easy. If I want to override that symmetry problem, I can just place these. I can just place them individual so we don't have to worry about symmetry. But something to think about. If we do make this in symmetry, right? If we do that, and we're relying on this hinge to lock into position and then auto-strutting over symmetry does give you some advantages. Here's what I mean. So we take this, we grandparent strut that. Grandparent strut attaches to the part 2 parts ahead of this thing in the hierarchy. So that's this piece right here. So we see auto struts on grandparent part going right there. Okay. Now take this part. We attach this part here. This part, let's grandparent strut that. Well, if we grandparent strut that, it's going to attach to this one because it's every other part. So this is the child part. That's the parent part. That's the grandparent part. Family trees, right? So if you hit grandparent part, it's going to strut there. You go two degrees of separation, so meaning 2 parts off symmetry. Watch this. Watch what these parts do. Where do you think these are going to run? Well, these are going to run to there, right? But you got to remember, that's the first part we placed in 4x symmetry. Watch what the auto struts do. Did you see it? Here, let me turn on auto struts. You can go into the physics tab in here in the debug menu and hit visualize auto struts. Look at that. What did that do? Auto strutting picks up on symmetry nodes. So this, because it's in 4x symmetry, right, is going to run auto struts from here to there, and then it's going to run from here to there. It's going to run a strut from there to there, and it's going to run a strut from there to there. It gives you this crazy geometric pattern because now you have 4 auto struts for the price of 1. This is very useful. That's very useful for making something extremely freaking strong. 2 degrees of separation off symmetry will allow the auto struts to move over in symmetry like that. And then, if you keep doing it, well, guess what? You got a nice lattice strut system here. This system right here is how I make Launchpad so strong. That. See that right there? Very, very useful. Oh, yeah. Look at that. That looks like a mobile launcher. That looks like the launch umbilical tower for an ML. How do you think I made the catch tower for the rocket that I showed off earlier where we catched it with chopsticks? How do you think I made it so strong? Abusing hierarchy. That's a lot of free struts. Bingo. Free struts that don't affect performance. How many struts would this thing be? You have 4 struts for 4x symmetry, right? And then, so that's 16 per part. We're saving 16, 32, and then 2 more, 64. That's 64 parts saved. This does exactly the same thing if you had 64 parts worth of struts. And it doesn't affect performance too much. Auto strut, adding a lot of auto strut information does screw with performance just a little bit, but it's not nearly as much as if there were struts here. Oh, not even close. You can abuse that. Now, if you look down here, so if I have the landing leg fold out and I have parts that are 2 degrees of separation off symmetry, what's it going to do? When this thing moves up into position, now you can't auto strut through a robotic part. You can't auto strut through a robotic part unless it's locked. So if we did this right and we were smart, if I folded this thing out and we had whatever part that we want auto strut 2 degrees of separation off of this cubic octag strut right there, and we set grandparent part correctly, well, if the landing leg closes down into the lock position and they actually do lock out, that auto strut will bypass, it'll go through, and it'll grandparent strut to this, but 4 times over because we're in 4 times symmetry. Same exact idea. This is why I want auto struts to lock out so much, because I could make it I could get it to a point where it literally wouldn't drift, and it would be probably the strongest hinge we could possibly make. That coupled with hybrid tech is a very potent solution here. This is what I've been trying to push for. This is what I've been trying to get done right. This takes time. But if we can dial it in, I can figure out a way to make hinges that are infinitely strong. And we have a robotic mechanism on our first stage, which we want to use a lot, that literally won't drift. So hierarchy with wing parts would similarly be strong, right? Sure. But you got to remember, floating really depends on what you're doing. This is a tool. This is a tool in your tool belt. You don't want to use this all the time. Like on the K90, on the K90, I only have certain parts of it that are grandparent strutted. Certain parts of it are grandparent strutted. Why? Well, I want the wings to flex a little bit. You always want the wings to flex a little bit under load, or else whoosh, they snap. You 154 the wings if you're not careful. See what I'm talking about? I can dial in structure in certain spots and get other spots to bend. I did this with pads too for the longest time to get pads to bend in spots where they needed to. I encountered an autostrut anomaly the other day. It caused crack and drift on parts of the vessel. Editing the autostruts out of a quick save snapped the parts back. Weird stuff. Something must have been under load when you saved it. And see, another thing here, fellas, is just on a side note, I said that I strutted the tanks together like this to mimic an ISO grid. The reality of that situation is that if you grandparent strut stuff like this up the side, you grandparent strut stuff, you know, tank, you're just going to get a straight line of struts. A straight line of struts like that, consider looking at this like a bridge. If you have just a flat surface bridge, it's going to bend, right? It's going to bend. And consider what we're doing with this rocket. We have to take this rocket, we have to grab the top, we have to take it vertical, and we have to put it on the pad, right? It's extremely susceptible to shear load. That would be a shear load when you're going on the transverse axis. That's why I have the tanks slightly overlapped. I have a lot of tanks, and every tank is strutted to every other tank. These mimic grandparent struts, right? So like this tank is strutted to this tank, but on top of the grandparent strut going up the center line, I have it triangulated. I have the struts triangulated. Those are triangulated grandparent struts. And that makes it so this thing does not move up and down. It's not very susceptible to shear load. It won't bend. And it won't wear over time. Also known as the bendy bus load. Yeah, indeed. I made a shuttle with several wing parts, squares, for a finer shape, but auto-strutted them to heaviest part. I don't do that. Don't do that. Floating, if you ever dock that shuttle to anything, station, whatnot, whatever, and you, for whatever reason, flip the flow of the hierarchy on the shuttle, it's going to explode. Your heaviest part struts will try to run all in different directions, and if the heaviest part struts run too far through the hierarchy, the game explodes. Do not use heaviest part unless you absolutely have to. Don't do that. I'm serious about that. Don't do it. Not a good idea. Have you ever tried same vessel collision on the tanks just to have their ends lean on each other with no clipping? No, I haven't. I haven't tested it. I'm not sure if that'll work better or worse. Yeah, that's why I don't use root unless I absolutely have to, and I don't use heaviest unless I absolutely have to. Because, once again, I deal with a lot of parts docking and undocking from each other. You saw what reversing the flow did to that subassembly. It screwed it up, didn't it? It screwed up the way it attaches, right? You reverse the flow on a part that has a heaviest part auto strut, the game really, really does not like that. No, it gets really mad at you. Same thing goes for robotics. You reverse the hierarchy on a robotic part, it inverts the numbers. Yeah. Oh yeah. It'll put all this in reverse. You'll divide this by 0, and the robotic part will just be like, I don't know what I'm doing. So which one should you use? Use grandparent strut. And then I like using same vessel collision to make things stronger. Yeah. There is no... Okay, so... Look at my desktop background. This is my desktop background here, right? There is no conceivable situation where you would run a strut from the shuttle main engine, where you'd have a structural piece go from the shuttle main engine to that PMM right there. There's no reason to do that. Well, guess what? If you're docking your shuttle to your ISS and that's your heaviest part, your shuttle has landing gear on it. Landing gear go through heaviest part. So it's going to run that. There's nothing you can do about it. Me, what I do is I come up with ways to make it so the landing gear don't try to strut to, like, over here. Because if they do, it's going to bend the station. And your station will just break. I always put the heaviest part near what I'm docking in the hierarchy so the struts don't screw up. Because sometimes when you dock, you're going to reverse the hierarchy no matter what. I call that my 5 degrees of separation rule. Or 6 degrees of separation. You guys ever know that you know the funny game 6 Degrees of Separation with Kevin Bacon? You can connect Kevin Bacon to any actor or actress because he's been in so many movies from like through 6 degrees of separation. So Kevin Bacon was in a movie with actor A, who was in a movie with actor B, who was in a movie with actor C. And actor C is 4 degrees of separation away, right? Any interfacing device that you're using, so docking ports, landing gear are interfacing to the ground, right? Docking ports and landing gear are the big principal ones, right? Any interfacing device, you need that close to your root part or on the center line hierarchy. And you shouldn't really be more than 6 degrees away. 6 degrees is just a number that I made up that I know that'll work. I don't know what the theoretical maximum is. So, what do I mean by that? All right, let's take a look. That's my umbilical. That's where we fuel. And don't get me wrong, that's not the structural connection to the rocket. It's not. The structural connection is there. The docking port is part of the hierarchy when the rocket is attached to the pad, though, isn't it? That's attached to the fairing. 1, 2, 3, 4, 5, 6, 7, 8. So this one is 8 degrees of separation. I know this will work because we've tested it on the pad. 6 degrees is a good rule of thumb, but that docking port is not that far from that docking port, and no matter what, no matter how you reverse the hierarchy on this thing, right? So say I reverse the hierarchy starts with that as root part. We attach it to the pad. Now that's the root part. If you reverse the hierarchy here, it doesn't change the auto struts too much because any part that's using auto struts here in symmetry nodes is attached to the fairing. And the docking port's attached to the fairing as well, so it won't screw with those auto struts. This is what I mean. That's very, very important to understand as well. If this docking port was attached to an engine, well, the engines are in symmetry. It'd undo all these symmetry nodes. And if these had a heaviest part auto strut on them, guess what? That's gone. So if you went to reuse the rocket, it would bend out of shape. That's the problem that I had with the Freedom rockets. I didn't get the hierarchy done exactly right, and the engines did just bend out of shape. That was mostly because I didn't strut them enough, but reversing the hierarchy did screw with them. Oh, that's cool, Koopsy. Nice. What's the advantage for same vessel collision? Well, you can use it to make a hinge. You can use it to make a bunch of stuff. Same vessel collision is great for structure. So when my upper stage, if you notice, this is where the upper stage is going to attach, right? That's where the upper stage is attaching. Just a small docking port? Well, yeah, that's all I need. I don't need that. I don't use my docking ports for structure. That's not smart. I have the fairing on same vessel collision, and then my upper stage is made out of these tanks right here. And my upper stage tank has same vessel collision on it too. Now the fairing is absorbing the structure and not the docking port. So I don't need to worry about the docking port bending and flexing because this is pushing up against the fairing. It's pushing against it. There you go. There's your structure right there. This is working like a flange, and then the docking port is just the bolt that holds the flange together. What happens when landing gear tries to interface with reverse root part as the ground? What happens when landing gear tries to interface with reversed root part on the ground? You can get Kraken strikes because your auto struts aren't strutting to the same spot that they were previously. That makes sense? Hey Aura, what's going on? Now, don't get me wrong, sometimes Sometimes they'll, you dock to the station, it reverses the hierarchy of flow, and then you undock from the stations and it goes back to normal. And then you land just fine. But if you have a rocket that has like a fuel tank, and on the way up, they're strutted to that fuel tank, you undock, now they're not going to be strutted to that fuel tank because there's no fuel because you're coming in for a landing, right? You have to make sure that they're always going to auto-strut to whatever, to the same thing, even if you reverse it or unreverse it. That's something that's really important to understand. I'm making a finalized version of the legs, but I had to explain some things with hierarchy, Rocket Guy. I'm just going to make this thing in 1x symmetry. Okay. Alright, now I gotta get back into thinking about this. Alright, so this is these pieces right here, the hinge outer parts are connected to that cubic octag, right? The hierarchy, maybe I should put this down here, right? Let's get that cubic octag right on the center pivot point. And now I'm going to take these and move them back into position. Now let's make sure that this still works correctly. Make sure the hybrid tech strut works right. Here we go. Yes, it does. All right. Go into your action groups. Make sure I still have this enabled. Yep. Okay. Yeah, Rocket, I needed to explain some things as to why I built hybrid tech the way I do. And I can't, that was just kind of a mock-up with the wings and everything that you saw before. I'm finalizing that design. I opted for something a little bit different than a straight telescopic strut because of hierarchy. This is going to be kind of like SpaceX's legs, but kind of not. I have a single telescoping, or not a single, we have a telescoping piston here, right? That's going to push basically a wishbone style landing leg, so something like this, right? And the way that's going to be mounted is kind of like upwards like this. And then this thing is going to push and that landing leg is going to fold out. Does that make sense? It would be like if we took Starhopper's legs and made this part right here telescopic. And then there was a hinge right here, a hinge right here, and a hinge right there. And then I'm using hybrid tech to tie it all together. Oh no. Don't hit undo. Undo breaks stuff. Undo corrupts craft files in this game. Don't do it. Well, the back fell off. The back fell off, chat. Rocket Guy was messing with flow priority. Down here is flow priority. And then up here is tank number. And then we have initial mass, half fuel, final mass. Good thing I incessantly hit the save button. The only thing that we lost was moving that cubic octag into position. So I'm going to undo this. I'm going to make one leg at a time. Saw that? Dig it? Right on. I redid these calculations since you were here last, Rocket Guy. I redid them to show where it is without the landing legs off. That's why I took the landing legs off, and then I built, you know, we got initial, half, and final with no landing legs attached. And then now I'm building the landing legs out so we can see the difference a little bit later. My head hurts just watching this. Good. That means you're learning something. Your brain starts to hurt when you learn new things. That's not true at all. Please go to the hospital if your brain hurts. Just kidding. Rob, okay, so it's a little out there. We're a little out there with hierarchies and all this stuff. Is it at least entertaining? Like, honestly, it's like, you don't have to understand what's going on. If you like what you see, like, yeah. Imagine if my brain... if you don't understand what's going on, is it at least entertaining? You know? That's all I ask. Like, I hope I'm not boring people to death, you know? I don't want to James May everybody. Pray you had a Ford moment just now when all my brake fluid decided to promptly leave the brake line in favor of my wheel well. A Ford moment? Well, you blew a brake line. Leroy Jenkins. Just put feet on the bells. It'll be fine. Yeah, no, I'm good. Okay, let's figure out the degrees of rotation here for this now. So, I'm going to attach an I-beam here initially, right? See last, page 9 of that PDF is interesting. I saw this floating around on Twitter this afternoon. Yeah, Thomas, yeah. We'll discuss that during Space News. I love the Fusion, but it's had some annoying problems. Dude, Brimo's Fusion has never given me any problems. That must have been something from the factory or something, Prey. Or you did something to it that was outside of useful operation. Dude, I've never heard of Fusions blowing brake lines. Must have been a car that someone built on a Friday. Catch my drift. Okay, so let's just come up with the base structure for the landing leg here. Let's just use an I-beam for now. Never had a problem with them. I've had 3 fusions that my parents had a fusion. My parents had 2 fusions actually, and yeah, they never had issues. I don't want to use that as the attachment point. Okay, so here's what I'm gonna do. False, a critter bit your stupid wire. Well, that's considered out of operation. That's not very... I don't think that's recommended from the factory, Brimo, do you? Yeah, using a filter wrench to put stuff on. Cringe. Using a filter wrench to put a filter on is cringe, bro. Pretty cringe. Alright. So, I have the hinge, and then I have a cubic octag that has my hybrid tech on it, and then attached to that cubic octag I have the I-beams. So here's what we're going to need to do. Let's run one strut that works like a grandparent strut here to this. Let's try this. This might be a good way to do this. I don't know. Now, that's going to look a little strange when it's in the fold. Okay. It's going to look a little strange when it's in the folded up position, but whatever. Did you see that it screwed up? One of the struts didn't move. Let's try attaching the first strut to the hinge and then the second one to the I-beam. Let's see if that moves correctly. Yes, it does. Okay. So now what I'm going to do, we're going to do something a little weird here. Actually, you know what? Just so that strut isn't like peeking out like that, I'm going to move it down in here like this, and then I'm going to do the same here. And then, you know what? I decided I don't even like having that strut like that. So let's put it right there. Let's tuck that one in too. See what happens. Let's run it up there like that behind the I-beam so you can't see it. You'll only see it when the leg is deployed. Gotta be careful with that. Nah, you know what? Maybe I'll have it stick out. Yeah. Maybe we'll just keep the strut sticking out the entire time. That probably would look nicer. But then again, it looks disjointed as all heck when we're like this. Yeah, well, they made the wires. They make the wire shielding on newer cars out of hemp because it's more sustainable. Freaking clown shoes, man. Freaking clown shoes. That man is playing Galaga. You thought we wouldn't notice, but we did. Well done, Mr. Stark. It's actually my flight director. My flight director is playing Galaga. No. I understood that reference. Alright. So I'm going to try something a little strange here. I'm going to move these struts, or move the hinges out here for a second. And what we're going to do is I'm going to try running struts from here to this, like that, from there to there. And here I thought I'd be the millionth person to point it out. Nah, it seems good to me, man. Alright, now, can we move this and will the strut go with it? It did? Okay, so now we have to do the exact same operation to the other side. Alright, now let's make sure this all flows together correctly. Yep. This picture is just so slick. Yep. Yeah, I know, Prey. It's really funny. I know this is unrelated, but I think it's funny he's using Bush's flipped car to create tech content. Who, Bozzy? Oh, yeah. Yeah, right. It's the only time you're going to see it. Oh, man, it's 4 o'clock. Wow, where did the time go? Damn. kind of want to finish this while it's fresh in my mind, guys. If you don't mind. What I'm gonna do is, I don't like that strut looks like it's sitting out there like that, so I'm gonna make it, we're gonna do some smoke and mirrors here and make it look like it's attached to something like this. And now the landing legs will clip a little bit into the fuel tanks in certain areas, and I do have a hinge that just folds out of my engine section, which looks very strange. Which is why I wanted to use the small hinge in the first place, so that doesn't happen. We wouldn't need any of this, but I think this is going to be stronger. And I think because it's stronger, it's going to look like it's more likely to lock into position. Or because it's a stronger hinge, it's going to be more likely to lock into position. That's what I'm trying to say. At least I think. That's the theory. If not, if this doesn't like locking into position any more than the small hinge does, I'm going to switch to the small hinge because, well, frankly, it's lighter. Less mass. So, now that we have all the struts into the right spots, let's figure out how we want to do this. Now the telescoping part is, I don't know, it's going to have to be on a hinge as well, okay? And that hinge is going to have to be strong, just like the other hinges. What would be the right way to do this? Did you try something like what I showed you, or did you rule that out? I've been shown like 1,000 different things over the last couple of days, RJ. I honestly have no idea what you're talking about. Are you talking about your design where you have the, I frankly don't recall what you're telling me. To be honest with you, man, I'm sorry. I think 120 is really what we're... maybe 130. Okay.
Discovery, go at throttle.
Predominant, 41 months. My subscription is younger than you. Okay. So, right here is where we're going to have an issue. We need... If I have this, right? If we have these pieces right here, how is it going to start the outward motion? Pushing on this is just going to pop that hinge out. We need something to start the motion this way. And I'm thinking it might... That's kind of neat on this. That's what I made. I'm not sure how bad it would drift. I can't really see the hierarchy here, but I remember you showing me this. Audio from last night is no good, so no need to upload your end. All right, N9. That's good to know. All right. Oh, I see. So the I-beam, the RCS ball, and... yeah, the I-beam and the RCS ball are connected to the hydraulic, right? So when the hydraulic is in the retracted position, it's up there. And then the grip pad, the two grip pads are sandwiching that thing in position. So when you go to fully extend it, it holds that ball in position, right? The little grip pad is on a separate hinge. Yeah, okay. It folds out. This wouldn't drift as long as you could lock out your hydraulics. It should be fine. Yeah, that should work just fine. I like this application here. I want to make sure that this works, or I want to try to see if this works. If not, yeah, I suppose we could go simpler than that. What's the throw on these smaller telescoping hinges? 2.4. Exactly half, so we need 4 parts. Landing gear were a pain starting back in the days of Alpha when there were no landing gear. Yep. What sort of parts do we have that are spring-like? I don't want to use a spring firework. I'm coming up with another solution. KSP never changes. You ain't kidding. Let's go with this right now. This is going to cause all kinds of drag. And I can't have it same vessel collision because... oh, wait, no, I can. That's not has... oh, yeah, we're using hold down points. I thought this was set to same vessel collider. I don't need to do that at all. This is fine. And that might even include the stupid thing. Excellent. Firework, what I'm going to do is just have something push it. Just push it out like that. No problem. Why are we reinventing the landing leg? Because I need a different design, because none of the landing legs in the game are doing what I want them to do to have the rocket do what I want it to do. I mean, I'm pretty sure that's pretty straightforward stuff. That will firework. That'll push us. That'll push the thing out. Yep, pretty much, fellas. Yeah, Wookie, I need something a little bit different. And we already tried making something like SpaceX's landing legs, but I think I got a better solution. It's literally Starhopper's landing legs, but if this thing right here was telescopic and there was a hinge right here, a hinge right here, and a hinge right there. Basically, these landing legs will start like this, and then they fold out and they flop down, and then all we have is just a huge telescoping rod that goes out this way that holds it into place. And then when these get fully extended, these things lock. The hydraulics will lock into position, and then the landing legs should be super freaking strong. They shouldn't move. I'm just wondering if I should use bigger or smaller landing legs. Smaller landing legs we'd be able to make a more compact design, but it would be more parts. And I'm not sure how strong it actually would be. Won't they be super rigid? Yeah. Yeah, that's... I hope. I mean, I hope. Yeah, I hope so. Could you also launch off of the landing legs and not need a pad? In Kerbal Foo-Face, yeah, sure, of course. But my whole idea is to go for some form of plausible realism, you know? In real life, the overpressure event from the engines firing just into a landing pad or whatever would cause some real problems. There's a reason why we have flame trenches on pads. Honestly, the rocket engines would fire and the whole... the explosion coming out of them would bounce off the ground and blow up the entire rocket. Yeah, that's why they stopped doing that. That's why they put flame trenches and stuff in. Because, yeah. Yeah, that doesn't end well. I wish that engine didn't have the rod sticking out of the sides. I'll make it look nice, don't worry. I'm not worried about them. There's gonna be so much stuff down here, dude, that you're not even gonna notice. Plus, when I do stuff like this, and we cover it up, you're not even going to notice them. Yeah, when we do stuff like that, you're not even gonna notice it, dude. You'll only notice it when the thing is landed. See what I'm talking about? But I'll take those off. I don't want those on there for now. It's distracting. Isn't that Rocket Lab's idea for Neutron? Kind of. Snow, kind of, but I don't think so. Maybe. Alright, we're gonna have to remake this, so get rid of that, get rid of that. Now, we need a good attachment point here. Don't hit undo. Undo will corrupt the craft file if you're not careful. Now, don't get me wrong, I'm sure people here have used the undo command in the editor to know, like, and had no problems with it in the past. When you're trying to do advanced hierarchy stuff like this, I don't bother. It'll break it. Alright. So let's get rid of this, get rid of that, get rid of this. We want that as our center mounting point. So let's do the same kind of thing that we did before. We know that that's lined up. Hey Maverick, my day's going just fine. How about you, buddy? Alright. Might be a dumb question. Why aren't the engines arranged to be more symmetrical with the hold downs? Seems rotated off by an odd amount. What are you talking about? I have the entire rocket tilted 15 degrees. Or, no, 45 degrees to one side because my legs are offset by 45. And I like to make sure that the local orientation of parts and the absolute orientation of parts match correctly. Because it's, yeah, it's easier to keep track of things. They do stuff like this in real life. That's why rockets are on processing rings that allow them to basically turn the rocket and do this with it. Know what I'm saying? Yeah, no problem, dude. Yeah, they do stuff like this with Falcon 9, so if all your technicians are down here and you need something, you need to work on an area where part B is, right? They can just flip the rocket over and then, like installing a landing leg, for instance. You just install one, it's locked in, rotate the rocket again, install the next one, rotate the rocket again, install the next one, rotate the rocket again, install the next one. That's how they put stuff together in real life. That's how they process rockets. They do that with Delta 4. They do that with Atlas. When it's in the factory, they do that with Falcon 9. Yeah, it's done all over the place. Rocket Guy's like, I do indeed know what you're saying. So in this particular case, I'm borrowing that. But that's just because I like to align my local and world orientation when I'm making a part. So that way I know that them being aligned, it's easier to keep track of parts moving around in my head. Yeah. If that makes any sense. So I'm not entirely sure what we're going to use for a hinge up here. You know what? Let's do this. Same hinge. let's use the same exact hinge and we'll see where it gets us. Get rid of that. Alright, so we don't need this, we don't need this, we don't need this. Now, what do we do about this? The hinge is going to be too wide. So, for this hinge, let's just, well, bring it in. Compact it. But I'm noticing something already, fellas. We're at 210 parts. Take this 4 times over. We might have a problem here. This thing's gonna be like 500 parts, the first stage by itself. So we gotta find a way we gotta find a way to try and reduce part count. So what I'm gonna do is I'm gonna get rid of one of these hinges. Now, this is not going to be nearly as strong, I don't think, but if I move the center hinge right in here, like this, it should theoretically do the exact same thing. Compact hybrid tech. Now, I'm going to go in here like this, and we got to select the thermometers, enable same vessel. We got to select the RCS ball, enable. And enable. Save. Okay. Hey, getting back into KSP again. I have a payload not staying in the cargo bay during landing. Is there a way to enable same vessel interaction from orbit? Right click, enable same vessel interaction. Can you get away with 4 thermometers? Untested. You might be able to, Rocket Guy. Maybe. But that's what I have, what I know works right now. We could try to test to refine that design down even more later. I wouldn't mind trying to mess with that. Alright, so it's important that these hinge motors are not engaged. This whole thing should rely on 2 hydraulics for articulation. We should have the pusher hydraulic right there. We should just have that pop out, and that'll push the legs, and then we extend the hydraulics from there. So we got our forward hinge here. And now the last thing we need is an interfacing hinge between the end of the landing leg and the end of the hydraulics. And then we got to get the throw correct as well, which is, yeah, that's going to be a little difficult. I'm debating using these, but you know what? Those are gonna drift more. Damn. All right, I'll use the big boys. We're gonna have to. Damping, no damping forces here. We were just doing this a second ago. Target extension, take this and make it so if I roll through the cow controller, it extends both of the hydraulics equally. Good. Going here, save. Note that I attached the cow controller to the leg subassembly, so if I need to remove the leg, the cow controller will come with it. That's just some good user implementation so I don't get confused. Now, Strongest hinge needs to be right here. The interface point between these. So what we're gonna do is I'm gonna adjust my play position. Now what hinge should we use for this? Okay. Hey, IQ, what's going on? Kerbal's been great. Yeah, Rocket. Yeah, I think Demo's right. Enabling auto strut probably would do that. This thing is gonna have to be... Okay. 200. What's the G11? 200. Alright, this hinge will probably be better. And this thing is straight up gonna have to be facing inwards like this for this design. Like this. Alright, now... Give me another hinge. And I'm gonna set the socket of the hinge to here. Socket's going to be in the center. And then socket is attached to the landing leg. And then the cup, or the hinge piece itself, is going to be attached to the robotic piece. Now we need to do some messing with this. Now, as a redundancy, I'm going to take a strut and attach that to the I-beam on the hinge. So they're connected via a strut, but they'll also be connected via same vessel collision. That should help with binding. It should kind of make sure that everything just kind of stays all together. And then I'm just going to put that strut right there so it holds in position. And then we're going to need something that touches the ground here. I'll just put a plate here on this and I want this thing deployed at 120 degrees like that. So that plate needs to be like this. That could cause an issue. Let's see. It's fine. Wouldn't it be good if the hinge is 179 degrees at 180, so the direction to bend out is already started? I have a hydraulic here that's going to solve that problem, Grumpy, but yes, you're right. But I want it to be compact. If these things are like this, it's going to cause all kinds of drag on this landing leg. I don't necessarily want that. Actually, that's not the final play position. Final play position is there. All right. Well, he's the grumpy older one. You're the grumpy old gamer. Differences. Okay. Let's make sure we have the enabled same vessel. Oh, no, not toggle. It has to be enabled, so we only hit it once. Save. Let me just go through and make sure everything is enabled the way we want. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right, we're good, dudes. Let's go. No, Maverick, I haven't. All right. Okay. All right, well, let's see what this gets us. I'm going to kind of open the landing leg in slow motion here and see what happens. There's a lot of grumpy people in chat. That's fine. It's okay. Let's see what this does, dudes. If you're wondering why the booster has all these numbers and markings on it, that's just for testing. It's my, it's just marking different points on the booster. Okay, so hit 1. Everything should lock into position. Okay. I need to make sure that this hinge doesn't have any power to it. The motor is disengaged. We got to make sure that's the same for this hinge right here. Motor needs to be disengaged. And then for the lower hinge down here, the motor's disengaged. Okay, cool. So let's go in here like this. And the first thing that we're gonna do is push out with this. And let's see if that should make the thing go like this. Okay, looks like I forgot an action group. Enable. Okay. Let's try that. That seems to be working now. Well, that's really weird. Whatever. Gotta push it out a little bit further than that. What's going on with you? Why are we binding up? Shouldn't be any binding up there. Gotta fix that. Tell me about your day. My day is going just fine, dude. Playing some awesome Kerbal. Building some really cool landing legs. I'm having a great day. Oh, that's almost exact. Wow, that should lock. We should get it torque and boop. I didn't get the landing pad thing just right, but thanks, Vulcan. I appreciate that, man. Thank you. Now, go there, we go there. What's the throw set on these hinges? 4.31. So that means I need to switch maximum value here to 4.31, right? Straighten the curve, copy it, put it down here, straighten that, and then set that to maximum length. And now we should unlock these and they shouldn't move. They should just be in that. We gotta strut that up and into position. Yeah. Okay. Alright, so lock it. Lock that. Lock that. Let's see what happens. This thing should tip over this way real quick. There was some play on that landing leg. Auto struts are gonna, yeah, we're gonna need to auto strut that. Okay, cool. Cool. Not bad. Not a bad start at all. What's making it springy? I didn't run some struts in certain areas, fellas. I can fix this. So take this, put it down here like this. Let's go here like that. Move this back into position. So I noticed some stuff was binding. That's binding like crazy. It's probably better if we just enable motorization on all of these, and then just manually shut the motors, or detorque the motors. First of all, this needs to rotate another 10 degrees. There we go. This thing, no damping on that one. We can't have any damping anywhere. The only place we really would want it is on these. Second part of this is that these aren't strutted correctly. What I need to do, and set play position to 25, and then set this to 431. There we go. We got the maximum throw for 130 degrees. Now we got to move this out of position for a second, and then I need to strut this to that. Because this is such a really big connection, that's very important for this to work right. We have to... That didn't attach to the right part. Still didn't attach to the right part. We have to move the whole hinge up. How heavy are those big pistons? Yes. Aren't they pretty overkill for what you're doing? Yeah, Dim, I already thought about that. So, yeah, they're overkill. So let's replace them with smaller hinges, right? That's 4 hinges. So 4 times the, or four of the small throw hinges. That's, or small throw hydraulics. It's 4 times the parts, and it's 4 times as likely to drift because I have 4 of these stacked in a row. Nah, I'll take the mass hit. It's better to take the mass hit, dude. Space News at 5? I don't know. I'll do Space News when I'm done here. I'm into this, man. I want to get this done. I really do. Saturday for the Minecraft streams, fellas. And then this guy right here, no damping, same vessel collision. Click on that, same vessel collision. There we go. All right. Save. Alright. Let's try this again. Let's test again. Another question about pistons. Why are you mounting them above the legs versus at the leg center line? That would resolve the length problem, and it's how the Falcon legs actually work. The legs would end up being a lot taller because the top landing leg attachment point should be around the center of mass. If it's not, you're going to get very big instability during landing. How long have you had this save? I've lost track, Coop, to be honest with you. I have no idea. Figure I'd be honest. Okay. No torque limiter there. No torque limiter there. Demo, when these things are in the open position, these things should end up pointing right at my final mass. This is final mass on the booster. So dry mass, they're supposed to point right at it. That'll make this thing super stable. Appreciate the honesty. Dude, I don't even remember. 2015? Maybe? I don't know. Okay. Plop the hinges out. It's backed up, dude. Yeah. Pistons don't need to line up with the center of mass. The leg geometry does. You'll have torques introduced because of the offset loading, but stability isn't the problem. No, Demo, I'm pretty sure that's wrong, actually. The legs need to line up. Explain Falcon 9. The legs aren't even pointing at the center of mass. They're pointing at the engine section. I don't understand what you're saying. That makes no sense. I don't get it. What? What you just said makes no sense. Yeah, like literally no sense. I honestly have no idea what you're talking about. No, your words aren't confusing at all. I understand what you're saying. You're saying the legs need to line up with the center. They need to be pointing at the center of mass, but Falcon 9 and New Shepard don't do that. I don't understand. That's not what I'm saying. The pistons don't need to line up with the center of mass. The leg geometry does. Car wheels don't point at the center of mass either. All right, draw it. I'm talking about the triangle that the leg makes with the center of mass. Yep. Are these your new online times, or is it a one-time thing so it would make my evenings much more entertaining? Dodo, I've been starting streams at 6 your time for like the past 2 or 3 years, man. Yeah, I always start at noon time. Noon my time, which would be, I think, 6 for you. I think that's what he's trying to say. In case you need to see that again. Predominant, it's binding up down here, which is very strange. It looks like these didn't have SVI enabled, but they did. Interesting. No problem, Dodo. Yeah, I'm here, man. I guess what I'm failing to understand with demos, whatever demo's saying, that I mean, I think I understand, but I probably don't. He's probably talking about something that's too advanced for me. I don't really understand what the benefits of that over this. Like, this works, and this works just fine. Why would we change it? I don't get it. All right. So here's what we're gonna do. I think this is cool. I think this is working how I want. So here's what we're gonna do. It should be very easy. To take this, copy it, Put it in 4 times. Get rid of this.
Discovery, go and throttle up.
Hey, Sam. Prior to landing, would you transfer fuel down to the bottom tank? No. No. I designed this around flow priority that simulates an oxidizer tank and a liquid fuel tank. No, I would not. So some of the struts did come undone, which is okay. That's fine. I can replace them. Banana. Banana, na, na. Twitch feels like it's changed a lot since the last time you've been on it. Yeah, I guess. Yeah. I gotta make sure that these struts came in correctly, and they didn't. Okay. Here. That was weird. Okay. Backspace RJ and then tab. Alright. Okay. I see it, demo. Now, what does this have to do with my landing design? My landing legs are... I don't know. I did what? So mine... If I have this attached at the... These are attached at center of mass line, so it's going to be like this already. I don't understand what you're trying to tell me. Like, what... Is there any advantage here? Or I'm actually asking. I'm really... You're honestly confusing the hell out of me. I don't know what you're getting at in context. I understand that. I see it. The right triangle, end of the landing leg, pointing right at the center of mass. I get it. I understand that. I just... Look at the second picture. You don't need to have it at the center of mass. Yeah, in practical physics, I don't, but I tried this the other day. I tried doing this the other day. I made SpaceX's landing legs with the hydraulic inside of the leg, and then it points out, and then it opens, right? I tried doing that the other day. This is really hard to get that to lock out. It won't lock out, and then it won't auto-strut, and then it won't work. Yeah, I understand that, but this does not... This is... Why would you do this? This is going to bind up your... This is going to bind up a lot of things, actually. I don't understand how... Why would this be better for me over what I have? I don't get it. This is going to be worse. This is going to put way more stress on my Kraken bearings. Like, way more. Why would I do this? The piston at the center of mass. Guys, what am I missing? All right, straight up, chat, what am I missing? Do you understand what he's getting at? I'm not, Demo, I'm not trying to be a dick. I straight up have no idea what you're like, I am so lost. I don't understand. Like, I'm honest, like, Demo wouldn't be telling me this unless he saw something that I didn't. I don't... I guess in KSP it'll be decided by how you mount the lower strut. Mine have the lowest hinge actually attached to the stage, so I just locked that out. Am I having a stroke? You're making my brain hurt, man. I'm just gonna keep building my hinge and go from there. Help, Sears Potato Bot just joined Minecraft server. I'm scared and I need an adult. Call drummer. Call drummer. Part of this is that I forgot you're using Kraken hinges on the legs, which I don't know if I understand the justification for. So, Demo, if you don't understand why I'm building it the way that I'm building, why are you making suggestions to fix something when you don't understand what I'm making? You're killing me, man. I don't, like, I missed it. I put these in there to prevent the hinges from drifting around. They're there to prevent the hinge drift. The hinges will drift. You could say, oh, well, mine just lock out when when we lower them into position. No, they'll still drift. They will. This makes it so they won't. These hinges are a lot stronger. I don't have to worry about stuff bending and binding as much. They still do to an extent, but it's not that big of a deal. Yeah, these are there for strength purposes. They're there to make it so it doesn't drift. None of this will drift around. Not under load, not under nothing. It won't drift. That's why I'm doing this the way that I'm doing it. Enable. Are the legs going to be separate crafts? No. Nope. Okay, fellas, I think I got everything here. Wait, is that a Supra? Yes. Your mother's a Supra. Got him. Alright, let's see. I think I have everything enabled. Guys, I'm not trying to be a jerk to people in chat. When I say I don't understand, I'm not trying to be a dick. That means I actually have no idea what's going on. I think that's an important thing to understand. When I say I don't understand, I mean it. I mean, I really, you might as well be speaking Japanese. I really don't mean to bug you on this, but why try to mitigate hinge drift through complicating it with Kraken Tech when you're already relying on a hinge that'll drift? Demo, do you... I don't understand why you're defaulting to that. Do you think that... Do you think that I just put hybrid tech in there for fun? You think I just put it in there for fun? Like, you really think if I figured out a way to make the hinges not drift, that I would just put it in here untested? Like, I don't understand. That's the part where I'm getting confused. You're just assuming you know how this design works and you know nothing about it. I wouldn't do this if I didn't know if it was going to work. I've already tested it. It does work. The hinges don't drift. This is undriftable. It won't, because same vessel collision will snap it back into position every time. It'll force it to snap back in every time. I think that's where we're getting confused. You're thinking, oh, well, why are you doing Kraken Tech if the hinge is going to drift? Well, the Kraken Tech is there to prevent it from drifting. That's the whole idea. You know what I'm saying? No, Sile, no. That doesn't get us anywhere. I gotta explain things. That's my job. I gotta be patient. That's also my job. So, let's get this to work. Wait, there's a way to stop drift? I thought all robotics drifted inherently. Same vessel collision, dude. Same vessel collision on physics-less parts. Attached to the robotics. Hybrid tech, man. See, here's the breakdown. You don't know what hybrid tech does. Hybrid tech makes undriftable hinges because I slave the Kraken tech right to the robotic. So it's Kraken tech with the robotics. It's hybrid tech, undriftable hinges. Oh yeah, they stay nice and stable. Yeah, they won't move. That's what I'm doing here. Because I want to reuse the booster a lot, so I put hybrid tech in to make sure that it doesn't do that. Does that make sense? What's going on over here? Why are you doing that? Stop this.
Discovery, go at throttle up.
Something isn't run correctly here. That makes sense. Still sucks that you're stuck with eight huge pistons, though. The main concern that started this. I already took that into account. When we did our initial delta V numbers, I figured in 12 tons of extra mass into the design for RTLS. So yeah, no, we're way in the clear with that one, man. I don't know why that one decided to pop out like that. I gotta figure out why this is getting bound up somewhere. Let's try flipping this hinge out. Nope. Somewhere there's a strut that's holding us up. I think it's the struts up here. Nice victory. Yeah, it's gonna take some time though. Man, something is wrong with this now, and I don't know what it is. I don't know. I was putting it together while I was explaining something and I missed what I did. I did something wrong. Looks like ball panels have wrong hierarchy. What is a ball panel? I don't know what the hell you're talking about. What do you mean? Ball panels have wrong hierarchy? What is that? Wait. I don't understand. I was trying to say the ground contact points. What do you mean they have wrong hierarchy? I don't. They're at the very end of the hierarchy. I don't understand. What does that mean, Firework? Yeah, Rarest, you ain't kidding. Oh, I think I know what's going on here. I think I know what's going on. That, right there. They were binding up. They were binding up because some of them were auto-attached. They weren't snapped into an absolute position. Okay. Is this thing really 300 parts? Maybe we can get rid of those. It's really 300 parts? Well, I guess we're gonna reuse it, so. Hey, Crex, what's going on? I can try your idea if you want. Thank you. I'll try it if I see the need to, man. How many parts is Condor's first stage? It's not, it can't be this many. Maybe, it might be, I don't know. I just can't help but think maybe a static landing leg might be the right idea. But let's see if we can get this to work, shall we? Get rid of that. Demotorize that. And then if we demotorize this, these should go slack right here. Ready? They didn't. All right. Okay. Yeah. Yeah, I got it. Okay. I know. Yeah, well, demo, yeah, we made hinges that don't drift. They don't. None of these things will drift. None of them. They're Kraken tech built in with the robotics. They don't drift. And if you can make a more precise hinge, dude, well, if you make a more precise hinge, that'll be easier to get these things to dial in because they'll be less susceptible to binding. Case in point, watch this, ready? See what I mean? And then those. This thing doesn't move that much, but I don't need that powered. It's on a Kraken hinge. So watch. Ready? See what this does. See what I mean? No bending. No binding. No nothing. You can't park there. It's a red zone. Shove your red zone. But locking legs in flight, in my experience, never works. Yeah, the precision of the hybrid tech should, I don't know, it should fix it. Rocket Guy, it should. Can we see a hop test? Oh, shnikes. Thoughts on implementing an aspect of Condor 9's landing architecture with hybrid tech? If I recall correctly, you were using those storage containers that open and clipped into the body to create a hinge, and you could replace those legs. Old storage containers. I love hybrid tech, man. Yeah. Rocket, I'm not 100% sure. I could do Condor 9s. Yeah. Actually, with hybrid tech, I have a version of this that has a Condor 9 style landing leg. And I wasn't able to dial it in time. Because I thought we would be better off with like a telescoping thing. And this is the telescoping thing. And it turns out that the telescoping hinge design is not that far off. It's just like what Demo was saying. I could flip the hydraulic upside down and have the hydraulic hinge right here connecting up there like that. We could do that. We could just turn that. Like, that's Falcon 9s. That's what he was talking about. I mean, either way would work here. But here, let's give it some altitude this time by fueling her up. But I also got to make a sequencer controller. So this is the landing leg deploy. So let's do this. Hey Trippy, what's going on, man? See last. What's up, 62? I think when you attach the landing legs at 4-sim, the triangle auto struts to the thermometers. Yes, that's exactly what happened. You got it, dude. Actually, you know what? Now, before I do this, Trippy, you reminded me. Let's just fix it right now. Those storage containers just may be able to help reduce part count. Storage containers. Rocket Guy, you know when you like get super focused on something and someone talks to you about something and you know that you know it, but they're talking to you and it makes no sense? Like, you'll be deep into like doing some project and somebody will be like, hey, did you leave your keys in the other room? And you'd be like, what are keys? I don't know what that means. Go away. That's what's going on right now. That's what's going on right now. I don't know what the hell you're talking about, man. The ones that have the doors that open, I don't know what they're called. The storage containers. The 1.5 meter part. Oh. Yeah, see? Car keys. Got it. Yeah? I'm not sure that's something other people... Yeah, sure, Pi. Well, we all can't have a golden memory of the gods like you. So, what was I messing with this? Here's a trick. You could set gear action group to start the landing leg cal, but also set it to reverse direction. Bingo, Wookie. Yeah. Oh, yeah. That's the part of the reason why I'm kind of splurging on part count here is because these will be able to be retracted by themselves. You use those for Condor 9 to replace 2 hinges at the bottom of each leg. They opened as well, which allowed you to replace the... Oh. When the hell did I do that? I used these for Condor 9 to replace 2 hinges at the bottom of each leg. I don't recall doing that. That's really, dude, that was a long time ago. That's when the service base used to be yellow, right? That's like 5 years ago, dude. Right? Did I dream this? I don't know. Maybe? Yes? I don't know. Yeah, okay. No, I vaguely recall that. Yes. 62, you're absolutely right. Look. It was a long time ago, back in 1955. I vaguely remember doing that, Rocket, but I just don't remember exactly what I did. I know what you're talking about, but and I know I wanted to make I wanted to make like a removable landing leg. I just don't remember how the service bay really fits into that equation, but I do vaguely remember it. Beautiful rocket and legs. Love it. What's up, 95? Yeah, guys, I'm not trying to be a jerk to people in chat. I'm just trying to figure out what the frick we were doing. That should fix this problem. Okay. If only could do half the things you do. Well, this just takes time. Pull up the VODs from 1955 to figure it out. Yes? No? Yeah, banana. Alright, let's get our sequencer correct. And we'll try to fly this sucker. And I'll try to deploy them. You can always be a jerk to me. I'm okay with that. Hey, shut up. Hey, why don't you shut the hell up now? Alright, so... Banana, nana. Alright, so we're gonna have to start with the motor disengaged on these. Okay, that needs to start in a locked state, and so does this. They both need to be started in a locked state. So, we have our landing leg sequencer. Here's what we're going to do. Take this. Go here like that. Landing leg sequencer. We need to... toggle lock. Toggle locked. Okay. Go here. Place that. Place that. Okay. So, now we need this. We need that hydraulic. Bound to target extension. And let's say this takes... yeah, we'll go with 15 seconds. This thing right here will go 2 seconds in. Add a point, plus the point in at 2 seconds, and that's in 4 times symmetry. Actually, set that to 1, and then plus in another point here at 2, and set 2 to... Okay, now I need the other cal sequencer right here, this one. Please tell me that still works. Okay. Remember, if you want cal function in both the res lock on, I'd rather, when we're folding the legs up wiki, I'd rather toggle it manually. I really want to be absolutely sure it works for deploy. You know what I mean? We'll just add it as a safing procedure, and then if I want to try to integrate the whole thing together later, I think that would be the right move. Alright, so the next thing I want is this hinge right here. Can we set the hinge power level? Can we set hinge power level? Click on this. Get... Damn it. I screwed up. Hang on. Okay, that's working correctly. So what I'm going to try to do is, let's go, give me the throw controller here. Landing leg deploy, not the throw controller. Okay, so now what's the next thing that we need? This thing. Give me this hinge. We can set our torque limit. Excellent. So the torque limit on the hinge can be set to unpowered, right? And then we're going to need target angle. And target angle...
Discovery, go at throttle up.
I did, Sile, real quick. We're going to test them all working in flight here in a second. Target angle should go right to 130 over time.
Discovery, go at throttle up.
Hey, Arsenal, 65-month resub. Thanks, man. And then... oh, this needs to start right here. I need to plus in a point right there at 2. Where's this one? Okay, I plus that in at 1.8, so we'll plus that in at 1.8 as well, because that's where it needs to stop. Value needs to be set to 0. Actually, plus it in at 1, right? There we go. That works. All right. So hang on, fellas. I'm not looking at chat for this part. I need to get this right in my head. At the very end here, towards the very end, we need to set the torque limit. So plus in here, and then the torque limit needs to go back to 100. And then... at the very end here, at the very end of the cow controller, we need to plus in... which one is this? That's toggle locked. We need to toggle in... actually, I see what you're saying. I see what you're saying, Wookie. Hold on. Disengage servo lock right here. Plus that in right there. And then for this one, we should have a disengage as well. Plus that in over here. Set that to 0. And now, when we're at the end of the Cala controller, we should have an engage servo lock over here. Right? Engage. Should be over here at the end. 15 seconds on the dot. Actually, it shouldn't be for that one. We don't need it for that one. It needs to be for this one. Engage servo lock. There we go. Over here, plus that in. Do you really need those small pistons? You could start the initial movement with the bottom alligator hinge. Simplifying and reducing parts RAID comes after we have an initial prototype. So you're probably right, but I'm not messing with that right now. Okay, now let's go back into the controller here. Get rid of that. Go back into the controller. Now what do we need? When this thing pushes out a little ways, right? Because that hinge isn't powered, it's going to be free floating and unlocked because I set power to 0. Now I'm going to need, we got to plus in the leg throw cal controller play position. Right? We got to plus it in here. So add a point right there and then move this point up there. And there we go. And then, you know what? that point where that cal controller is at 1, I want to set the time value to 13. Well, hang on. Let me plus in a point right here at actually 14 and set that to value 1 and keep it like that. And then we'll smooth out and tweak the curves like that so we get nice fluid motion. Okay. The reason why, because at the end of the throw right here, at the very end, what I want here is for you, I need a engage servo lock. Plus that in, 3PT hydraulic, engage servo lock, engage servo lock, plus in a point right here, move the servo locks down so they're near each other. Okay. And there, that should do it. That should do it in case I'm forgetting anything. What I will do additionally, just for testing purposes, here to AG0, engage lock, so I can spam that to see if it's working how I want. Engage servo lock, engage servo lock. So we could spam 0 if it doesn't lock into position. I can't believe it's already been 9 years since I first started following EJ on my alt TTV account. If I recall correctly, he was working construction and streaming after work. Loading dock. Those notorious sunglasses were a staple of the stream. Yeah. Hey, what was your alt account name, if you don't mind me asking? That's right, I worked on a loading dock. That's the last normie job that I had. It's not funny, weed. Chatty. Damn, dude. 1A, that might be so far back I might not remember, to be honest with you. But hey, thank you for coming back after all this time. I do appreciate it. Missed the normie job much? No. No, not at all. Okay, Wookie.
Discovery, go at throttle up.
Well, you got gifted a sub, Chatty. There you go. Or 1A3. No, I worked on a loading dock at Best Buy, Mike. Okay. All right, let's just do a manual actuation and see if that works. So, disengage the torque limiter here. Torque limiter's already disengaged down there because of the cal controller. So, disengage the limiter here. Unlock. Unlock. Okay. I didn't enable the Kraken Tech, guys. That was without Kraken Tech, to be honest with you. Hey, Bobber. I'm out of the loop for KSP. What are we currently doing? Engineering up some landing legs. I once said something about you having a Buzz Lightyear on a dresser behind you at your parents' house. You stood up, flipping out. How can you see that? Holy crap, dude. I remember that. I still have the Buzz Lightyear. It's still at my parents' house. Yeah, I do remember that. Yeah. It was over my left shoulder. Yeah. Right? It would have been like right here. Right? Yeah, I remember that. I was like, how the heck can you see that? Dude, I remember that. That's funny. Yeah, that's dude, that's going way back. I still have that Buzz Lightyear, dude. I still have it. Yeah. You still play without mods? For the most part, Mash. Now, Mash, I remember you. Yeah. Any thoughts on max impact velocity? I don't know. Probably not too much, Grumpy, but let's just say, look, I tried to engineer these things in a way that, well, if we hit the ground, I'm gonna move these all up one tick. If we hit the ground with enough force to destroy the landing legs, I'm fairly confident we would have just blown the rocket up anyway. So, you know.
Discovery, go at throttle up.
Yeah, Cyborg. Yep. Hey, Ren, what's going on? Neat. 87-month resub. All right, dudes. Let's try this again. I'm going to sequence this thing, and we're going to see if she works. And Wookie, I see what you're saying. The lockout on each side of the Cal controller needs to be a toggle, right? Yeah, you like the title, Sawyer? Yeah. 1A3, I remember that. Yeah. That was a long time ago, man. That was like 2014, dude. That was 8 years ago. We're doing this like Falcon 9 with no mods. More or less. Bobber. Yeah, more or less. Okay. So I hit 1 to enable it. Let's test this in slow motion, okay? Ready? Hello, Elon Musk. 111111111. I noticed something that I gotta mess with. Motor power on this hinge. We need to go into leg throw, or landing leg deploy. Go over here. And then I need to set the power limiter on these legs. So we need to go to torque limit on this, right? And the torque limiter basically needs to go like right here. Okay. That should be locked out. That should have no torque limit. And then that one should be locked out with no torque limit. This one should be locked out with full power, even though, I mean, it really doesn't matter. This thing, you know what? That thing doesn't need any limiter at all. Alright, fellas, let's see what this does now. Ready? What's so special about the way these work compared to your old setup? Hybrid tech. Hybrid tech uses Kraken tech to reinforce the robotic hinges in the game. They don't drift. They won't drift. Thought about changing my nick, but I found my nickname too hard for people to read. Oh, 1A3 is what I was saying. It's one eye. I got you. I got you with lead speak. Yeah, I got you. As I also have one. Most nicks are taken nowadays like that. Yeah, like back in 2011. Yep. Yeah, Murdoch, hybrid tech probably is the right way to do this. Okay, so now if I reverse it, what happens? Yeah, and this is what Wookie was talking about. Changing him to this. Have to say it looks cool. Thanks, man. Okay. Let me bind this old school Condor style to play sequence. AG9. So,
Discovery, go at throttle up.
that's pretty amazing. You should go back to school to do this professionally. Seriously, your potential is being wasted in a video game. It's pretty flattering. Yeah, it'd be nice. That would be nice, man. I'd love to. Part of me is just like, screw school. Just go find some free courseware and go from there. Who knows? Okay. Alright, let's see what we can see. Thrust limiter didn't go across all forms of symmetry, and we're gonna crash. Alright, cool. I was messing with the thrust limiter to get TWR values earlier. I screwed with the engines a little bit to make sure we would get 1.0 TWR, so when you throttle it up, it just kind of sits there. That was 1.0 TWR with no fuel, so we got to go back in here and do that. There we go. All right, I'll set those toggles in here. Actually, you know what? I'm just going to do it manually for now. We'll screw with it later. So let's go out here like this, set that there, move that there like that, go there to there. All right, cool. I think your tiny pistons are causing that snap-on retraction. Maybe.
No, we missed the boom! Where was the earth-shattering kaboom?
Don't worry, you'll see it now. I'm noticing something a little bit weird with our sequencer, particularly on end vessel. If we set this to 13, and then I go over here and we plus in a point at 130 up here like that, and then we straighten those curves out like that, that should fix that problem. Okay.
Discovery, go at throttle up.
Hey Firebird, what's up, dude? I may have loaded this down with a little too much fuel, so we'll just kind of chill and hover here for a moment. It's dust in the mouse. Come on, come back now. All we are is dust in a mouse, dude.
Discovery, go and throttle up.
DNF, strange error. Did it work? Yeah. Well, we're messing around up here.
Discovery, go and throttle up.
Hey, Dash Digital. Welcome to Mission Control. You go with throttle up. Thanks, guys. I'm glad you guys like this. It's fun, isn't it? When we get it right. It's fun when it works. we put it to you like that. DNF, I think we got a 60-monther there. I think it's working, man. What's our burn time? Okay, we got plenty of time. Nope. What's locked out? Is that locked out? Is that locked out? They're all locked out. Thanks, Fanny Pack. I'm glad you liked it. I'm glad you guys enjoy it. Your boys still got it, I think. Yep. I think this is more than enough, Chief. Now, here's the real key. Ready? What did we lose? The thermometers. The thermometers are at the end of the hinge, so we need to come up with a better bumper down here. It sucks that the cow can't do it, though. I hate that about robotics. I know the reason why it can't do it, Rocket Guy. Yeah, I can fix that right now. That worked, fellas. Worked really good, actually. Now, here, you want to see something crazy? Ready? We bent it. It bent from landing. Interesting. And then this one shouldn't have any thermometers. Yep. One of the thermometers isn't there. That's from... This is from bonking the ground. That's why it's binding like that. Yep. We bent one of the landing legs. That's all. But the other one should work just fine. Okay. Cool. Let me fix those problems with the cow controller now, and then we'll see what it does. I did break some of the thermometers. Yep. Offset the panel to prevent the thermal hinge from colliding with the terrain. Yep. Actually, Raid, what I was thinking about doing is just that. Cut into the terrain like a knife. That'll fix the problem. We just found a predictable failure mode. That's right. Alright, so we know that this works. So let's go into our landing leg sequencer, right? And the power stuff. Let's go right here. Plus in a point right there. Let's go to 1.0. Right? Select over here, then select this point, make that do that. Torque limit percentage needs to go to nothing really quickly. That'll help with locking and auto-locking, Rocket. It's the torque limiters. That's the key here. So we don't want an engaged servo lock here. Let's get rid of all the servo locking. Okay.
Discovery, go and throttle up.
Hey, Alleviate, 30-month resub. Let's go. Have you been? Been smashing flight sim VODs. Question on why did the Dark Star do an inversion before starting the scramjets? Going down, going up and going down, then going up again, getting the airspeed that you need. Alright, so now what we're going to do is go in here like this. Yeah, you got to get the airspeed to turn on the scramjet, just like the whiplash in Kerbal. Same idea. It's the hinge repowering that's screwing with this thing.
Discovery, go and throttle up.
That's the play position. Target angle. 1P2 hydraulic right here. Rocket Guy, this is what's screwing it up. I need this hinge. What time does that happen right there? 14. Okay, what time do I have power being driven back into the hinge? That needs to start at 14 right there. And then we need to go to like 14 and a half, 14.5, right? And then we need to set that value to 130 and then flatten that curve out.
Discovery, go at throttle up.
And then the overall shape, or the overall angle here of this thing, 14. We need to plus in a point here at 14.0 and set that value to max 130. That gives the hinges some buffer time to lock out. Cool. All right. That should fix everything, guys. This should be exactly what we're looking for. And this has the hinge toggles here. At least I think. I think this is going to do it. Let's test it. I have not seen Maverick yet, Steve. Novus, what's up, dude? Maybe stress test it by landing with more fuel than you ever have been coming back. Okay. Okay. It's those. Alright. I see. It's the servo lock for the telescoping hydraulics. The servo lock for the hydraulics is not working correctly. But it did. But wait a minute. I don't... One... Did I put... Is the servo lock on the cow controller? It's not on the cow controller. Wait. Why is it saying cannot lock servo? Huh. The aviators are right here. Okay. All right, Novus, we're gonna land this thing on. We're gonna land it with a pretty heavy fuel load. Bro. I would have to say that we made something pretty freaking cool here. It's supposed to have a little bit of give Ichi, but I mean, I bonked that thing into position. Here, let's raise it up again. The little bit of give looks like it's around the panel here. Nothing else is moving. You want just a little bit of give here. Okay. Here's the real test. Ready? Again. No drifting. I have a manual lock initiated for the cylinders right now. Yeah, this is a very beefed up version, Luke. How do they handle high velocity impacts? The give in the panels is what does it. Now don't get me wrong. I'm noticing from the TWR, from how the TWR stuff is working, that we're really going to need to be careful with this. We really can't come in too fast. But she ain't bad. Panels have some of the highest impact tolerance in the game, John. You got it. Yep. I'm just using a connection between two parts with an auto strut for my damping forces. And it works really well. Find the breaking point. I think that should break it pretty well. But, just like Falcon 9, the legs sack themselves. They sacrifice themselves to keep the booster in one piece. Eric, no. Launchpad with these legs, no. I don't know what that means. What happens if we do this? Yep. Yep, they'll bend and it'll sack the crush core, just like Condor. Only better. And then we just recover the booster. Whatever. I mean, that's a worst case scenario. Bouncy, 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 fun, fun, fun. So, I don't know if Rocket Guy, I don't know if you're still here, but the hybrid tech holds that stuff in place. It prevents hinges from binding as much. Everything stays nice and true. And because everything stays nice and true, really easy to lock stuff out. It takes 2 seconds. In fact, I'm going to do another test here. Landed from space? Well, I don't have all the control systems on it, Rooney, to do that. Not yet. You're thinking about a launch pad that doesn't drift using these legs. No, I wasn't, but also, yeah. That breaking point was 18 meters a second. I wouldn't exceed 10, which is pretty much in line with, like, actual Falcon 9. Part Cat Benno ended up at 327. But that's with all the flags and everything. So we're around 300 parts for the booster. It's not the worst. And we can there's certainly a lot to simplify here. But also, sometimes you got to pay that higher part count. You got to pay the higher part count because You want reusability. That's the price you pay. How's it going to survive re-entry? Parts in Kerbal have pretty high heat tolerances, fellas. I wouldn't worry about it too much. She works good, though. Give these things some wing cladding and call it a day. I don't know how we're gonna do it, but is it an SSTO? This could probably SSTO by itself. I mean, yeah, I mean, it probably could. Yeah, it could. There's really not a good need for that. Like, what is it? Okay, it gets itself up there. Great. How would this leg design scale for a super heavy vehicle? I don't know, Phil. We might need to come up with some other elaborate solutions. I don't know how it would scale with this. Yeah, Luffy, different upper stages. I mean, it's possible. We could do it. Any idea as to how much weight this has added? So the current wet mass on this thing I had it set at 270 tons, so let's fill her up. We're at 270, 269, nice, 0.24, and now it's at 282, 121. So we've added about 10 tons worth of stuff. Actually, it's more like 12. Which, you know what, is right in line, because I figured... Did I figure 3 or 4 ore tanks for this thing? I think wonky tapers are not explored enough in Kerbal. Loopy, I plan on giving this a 375 upper stage. I want to basically give this thing Gemstone 4's upper stage. That's what I'm looking for. Now we just got to figure out some shrouding for it. Get some wing stabilization. I've almost done it, Jack. Close. Yeah, almost. Yeah, here's the concept. That's what we're looking for. I might consider giving it a bigger fairing. I don't know. I think it looks fine. I think this thing looks great. It's gonna look real nice. I use this to do my delta V calculations. Get a bigger fairing in true Tory fashion if the market demands it. She's coming along real good, man. I'm really proud of this. I'm really proud of those landing legs that we just made. That hybrid tech, dude. I'm telling you, game changer. Now, how do we make this thing look freaking sick? That would be kind of cool, what I'm thinking. What if we... Okay, let me go back to what I had at the beginning of the stream, right? Let's go back to this. Ready? Different thickness. Okay. All right, let's do that. Gonna need to fix that. Okay. So save this. Aha. Piss. Piss.
Discovery, go and throttle up.
What are we building now? Yes. Yes, we are building. So what I'm trying to do is make like a sheathing for this thing. So if we... But I want the sheathing to kind of come apart in the center, and then this part that I have highlighted will fold down with the legs, and then this part will stay with the hydraulics. So it'll look like a landing leg, and then it'll come apart, and this will go out like that. But the problem is I'm having some weird hierarchical problems because my landing legs are 45 degrees offset, and then a mirror symmetry node based off of that is kind of strange. The game doesn't really understand it, so I'll give you kind of a little rundown here as to how this could look.
Discovery, go at throttle up.
Hey Jack, EJ building stuff that shouldn't be possible in stock KSP, that's what I like to see. I try. I'm trying, man. That could do with some work. Yeah. Alright. I'll have to come up with a better profile for it. We'll have to come up with a better profile and a better... Not necessarily better landing leg design. I mean, honestly, it might just be as simple as doing this. It might be as simple as that. Yeah, that looks a little weird. I might need to redo some of this. Or, not redo it. We'll come up with a better landing leg design. Maybe use grip strips to go down the center. That's not a bad idea, Loopy. I'm just... That's gonna take... I only have so much creative juice during the day, right? I used most of it already. I used most of it making this. I'm not gonna lie to you. I used most of that with this today. I'm very, very proud of this and how it's working. It is... You know what? This makes me want to try SpaceX style landing legs. This makes me want to try their flipper legs and see if it works. I want another stab at it, man. Oh, that's so messed up. But my design works too. Have you seen the hyper-encabulator video? The hyper-encabulator.
The original machine had a base plate of prefamulated amulite, surmounted by a malleable logarithmic casing, in such a way that the two spurving bearings were in a direct line with a panometric
Nice,
fan.
Sunti, that's cool.
Yes, that was once me, extolling the virtues of retroencabulation. Now, I may not be the dashing young on-camera narrator I once was, but if history tells me anything, it's that the Battle of Hastings was fought in 1066. But that's not the point. The point is that encabulation has a rich, sumptuous history with a delicate, flaky crust, relatively unknown to emergent cybersecurity personnel. Allow me to elucidate. The discovery of encabulation was quite accidental when engineers in the skunk works at Mutual Polydynamics coupled a transcendental Hopper datoscope with a spiral decommutator via the application of anhydrous angling pins, resulting in a device that allowed frenetic mastication at alarming speeds. The device was kept secret for many years, owing to the horrific accident that occurred shortly after its inception. Howsoever, the U.S. Compartment of Defense and the National Guard soon realized its potential as a weapon of choice, leading to its next iteration, the hydroencabulator, which they nicknamed Fat Boy Slim. Understanding the grisly bare fact of the devastation that would result from its deployment, the project was retubed and transmogrified for industrial supplications. This version, known as the pseudo-encabulator, was the infernal Faustian engine that allowed post-war America to realize its aspirations and become the domino player on the world stage.
Show dominoes.
Everybody was encabulating.
I don't understand you.
Well, I knew you wouldn't, but if I'd have told you before, the answer meter on the other side prenulates the canoe to spell hepulous, and that's the entire secret. There you have it.
During
That
the
was the
tumultuous
president.
60s, the psycho-funkadelic vinyl encabulator emerged as the long-haired hippie people's answer to their parents' aging technology, scarving a resonance groove in the hot wax of a new generation of encabulators. However, interest in encabulation waned precipitously until the late 80s, when the public was ready for the next transubstantiation of encabulation, the extraordinarily populist turbo-encabulator.
Now, basically, the only new principle involved is that instead of power being generated by the relative motion of conductors and fluxes, it is produced by the modial interaction of magneto-reluctance and capacitive directance.
Which brings us to where we are today, floundering in the wake of the obscenely similar retroencabulator, featuring yours truly, living proof that leveraging existing assets is not plagiarism. Now, despite encabulation's unparalleled success in reducing sinusoidal depleneration through advanced dingle arm technology, it has failed to meet the unanticipated needs of the cybersecurity industry to create zero-trust operations in level 0 monitoring environments to ameliorate zero-day process attacks. That is why, despite zero interest from industry, the SANS ICS security team has taken it upon themselves to develop an entirely new level of encabulation, unresponsive to the needs of the average consumer and undoubtedly without merit in terms of concomitant asynchronous communication with client-side connectivity. Ladies and gentlemen, ISACs of all sectors, beer included, and children of all ages, may I present the hyper-encabulator. The hyper-encabulator is nothing less than a key ruminant in the advancement of retrograde phenomenology, by which we can achieve results that are plastic, spastic, and synosynclastic without sacrificing both normative reality and AI-informed modalities. You'll note that the hyper-encabulator utilizes indiscrete modules, making possible virtualized environments that include PLC-controlled stand-up reheaters, as well as Retanium-based cloud benders.
Ah, yes.
It also includes a dedicated OT Security Operations Center access panel, known as the sock drawer. The primary modules of the hyper-encabulator are stackable, DIN-rackable, and unhackable. And please note the complete absence of side fumbling, owing to the maintenance of tolerances allowing a tight conniption fit. Please take little note of this module.
Go and throttle up.
the open-source digital ghost daemon, which allows transparent OT invisibility owing entirely to the manipulation of airborne particulate matter and single-surface reflective devices. Or, for criminal infrastructure sectors where the dependability of supramotive Wendelsprecks is essential,
Yes.
our handsome ransomware hypervisor is perpetually alert to SQL injections of Gates tracking chips and quantum IoT identification dots. Moreover, whenever a pen test is elected to assure the integrity of a safety instrumented system, our Purdue model modal module defeathers and plucks clean every proverbial fox in the henhouse and keeps would-be intruders wondering which metaphor got mixed first. As you can see, the hyperencabulator has reached a high level of development. Whereas previous dissimilar devices operated under the concept of manumatic stressor reduction and macroeconomic supply chain SBOMs, the hyperencabulator operates totally under the principle of colonic effluvium expulsion and audible gaseous eructations. Thomas Edison once said that invention was 10% inspiration and 90% perspiration. If that's the case, Thomas Edison should have invented deodorant. But I regress. In the near future, hyperencabulation will ultimately replace all traditional cybersecurity safeguarding processes with osculating segmentation and entropic astrogation, making what was once thought to be impossible, probable. At SANS ICS Security, when we're not innovating, we're encabulating.
Yep. What the fuck? What? Did he say it operates from farting? Oh my god. Ham Jandy! What the? What the? Sunti, you gotta go into your interview and just say that. Just say that whole thing. They'll hire you on the spot. He said perspiration. So Thomas Edison should have invented deodorant. What the absolute shit? My brain hurts. We call it the sock drawer. Clearly an evolution of the studies of the Peruvian scatological research from older generations. Yes. They clearly, I mean, Dish, like on a complete serious note, they clearly have elaborated on the retroencabulation, which is based off of the turboencabulation from the pseudoencabulator in that. It's very, very apparent that it's reached a very high level of development at this point, especially with the inclusion of the sock drawer and the, perspiration equipment that is associated with that. Yep. Yes, Van. Yep. Yep. Jason, what's that? Oh, the old school hinge design. Yeah. I'll think about it. Crane. Oh, they're building her. Wait, I need to review one particular part of it, guys, if you don't mind. Right here.
Reached a high level of development. Whereas previous dissimilar devices operated under the concept of manumatic stressor reduction and macroeconomic supply chain SBOMs, the hyperencabulator operates totally under the principle of colonic effluvium expulsion and audible gaseous eructations.
Colonic effluvium expulsion. Farting. Yeah, it operates from farting. Okay. Audible gaseous eructations. Farting. Okay. Farting and burping. Lovely. Yep. We call it the sock drawer.
Thomas Edison once said that invention was 10% inspiration and 90% perspiration.
No, it's perseverance, damn it, not pers.
If that's the case, Thomas Edison should have invented deodorant. But I regress. In the near future,
Regress?
hyperencabulation will ultimately replace all traditional cybersecurity safeguarding processes with osculating segmentation and entropic astrogation, making what was once thought to be impossible probable. At SANS ICS Security, when we're not innovating, we're encabulating.
Ham Jandy. Ham Jandy. Oh God, that just made my day. The hell is SANS ICS? Industrial Control System Security.
The original machine had a base plate of prefamulated amulite, surmounted by a malleable logarithmic casing, in such a way that the two spurving bearings were in a direct line with a panometric fam. The lineup consisted simply
problem,
of 6
Jason. Yeah, I got 'em.
hydrocoptic Marsal vanes, so fitted to the ambifacient lunar wane shaft that side fumbling was effectively prevented.
If you're a fan of retroencabulation,
Oh,
and
I am.
know that you are,
Yep.
you won't want to miss the
knows.
SANS ICS Security Summit and Training kicking off on June 1st in Orlando, Florida. This ICS security event is going to have it all. Live attack demos, hands-on skills tests, CTF walkthroughs, grid net wars, and more. And to top things off, SANS ICS will be introducing a whole new level of encabulation featuring me, the older but wiser retro-encabulator guy, live and in person. For more information, go to this website.
What? I Right. Should we start space news now? Just you guys smell that?